development and sustainability here in Hall A. Over the past 2 days, we have enjoyed inspiring talks and research that sparked excellent discussions on sustainability, clean energy, and innovative technologies. Today, we continue with another program of keynote and invited speakers, along with technical sessions that will close our symposium. We begin with our keynote speakers, Professor Alexander Zaporozhets from the Center of Aviation Technologies of the Kyiv Institute of Aviation, who will speak on sustainable aviation fuel, contribution in European Union Clean Aviation Program goals. And Professor Mikhail Sheremet from Tomsk State University, presenting on fluid flow and heat transfer in heat pipes, numerical simulation and applications. Then we move on to our invited speakers. Andrea Voigt, Head of Global Public, Industry Affairs and Communication at Danfoss Climate Solutions. Professor Serhiy Boychenko from the National Technical University of Ukraine. And Professor Serhat Burmaoğlu from Izmir Khatib Çelebi University. We will then move on to our technical presentations. At that point, our chair, Professor Mehmet Ziya Saud of Piri University, will lead the first session. Then the participants are invited to take a short break before we begin our afternoon session. After the break, we start with our keynote speakers, Professor Hakan Öztürk from Fırat University, Professor Jean Sintah from Saints University, Professor Özgür Çoplan from 9 Eylül University, and Professor Dinesh Balasubramanian from MEPCO Schwenk Engineering College. The session will conclude with technical presentations. Then our chair, Professor Turhan Çoban of Piri University, will guide the second session. That concludes our program for day 3 and also the closing of ISEMAS 2025. Now I invite Professor Mehmet Ziya Saud of Piri University to lead the session. The floor is yours, Professor.
Thank you, Sofia. Good morning, everyone. Good morning. Welcome our last day in ISEMAS 2025 and International Symposium on Energy Management and Sustainability. Today we have many different subjects and we have many different presenters. First presenter, the Professor Alexander Zaporozhets, Center of the Aviation Technologies and Institute of the Aviations, related to his speech that sustainable aviation fuel contributions in Euro Clean Aviation Program goals. Professor Zaporozhets here.
Yes, I'm here.
Good morning, Professor. Welcome again.
Thank you very much, Professor Sugut. And first of all, I wish to say thank you very much for inviting me to this conference. And I wish to say congratulations to all of you that conference is working. And I'm very sure with very good results at the end of this work.
Okay, stage is yours, Professor.
Yes, I'm preparing my presentation. Do you see presentation on the screen?
Yes, Professor. Yes.
Yes, thank you very much. And I'm starting.
Yeah, yes.
Of course, last 3 years, as you know, I'm working in Warsaw in Institute of Aviation, but I'm still involved in a number of European projects, and about one of them I will talk today. And this project is completely concerns about new ideas in sustainable aviation transportation in Europe, in global issue, and so on. I mostly will use the results from our project IFACA. And few words about this project I will say to you in the beginning of my presentation. But taking in mind the main idea of the symposium, I will talk mostly about the contribution of sustainable fuels to the problem which should be solved in aviation sector in near future. Of course, aviation is a big system, and this system may be characterized by a number of factors of influence on environment. All of you and all of us mostly concerned about aircraft noise, about local air quality in airports, but last 5-7 years, of course, climate change, global issues are priority number one in aviation sector and in other sectors of our mankind. What it means climate change for aviation sector, I will talk once again today very briefly, only emphasizing on main ideas which influence the scientific research for this impact analysis and where we are and where we are going in this situation. Climate change, of course, it is an issue, global issue, and everybody is involved how to solve the situation to be prevented from these changes. And of course, aviation is involved in this work, and I must say that this effect on climate system is not directly concerned by only CO2 emission. So a number other important contributors exist which may be compared to the influence of CO2 emission produced by aircraft flights, and even more, some of them contribute little bit higher value of changes than CO2 emission itself. The latest scientific research, as you see from diagram on the yes. Okay, as you see on diagram on the right, cirrus contrails, which are produced in humidity regions where aircraft fly, they even may provide much more radiative forcing, which is term used for climate change influence, which is a little bit higher today assessed than contribution from carbon dioxide. Of course, confidence of this assessment is still low. You see, once again, these confidence limits on the diagram, but we must include in mind that not only fuel burn and produced by fuel burn CO2 emission influence these radiative forces and climate temperature change as a result. Of course, aviation sector, global aviation sector or regional included in global economy, and IPCC, International Platform for International Panel for Climate Change Issues, provided the current vision where we are at the moment every 5 years. They provided scientific view on situation we reached, and during the last 2 decades they provided the vision where we need to go to be prevented from these big changes. And you know that latest vision that temperature rise should not be higher than 1.5 Celsius degrees in global issue. So for that, of course, a number of strategies were provided, and a number of strategies were provided for aviation sector. ICAO, International Civil Aviation Organization, as a member of United Nations, they provided once again assessment and strategy how aviation sector should be developed, and in this case, of course, what kind of new aircraft should be produced, and how these new aircraft and new operational and maintenance principles should prevent the aviation sector from climate change problems. The same ideas exist in European region. You know, directive for Green Deal, and to be sure that this Green Deal directive is working correctly, intermediate point Fit for 55 document was produced, and in accordance to this document, the vision of strategical development of the aviation sector also was produced in European Union. Of course, everything depends what kind of energy we use and how this energy is used. And you see from this diagram that renewable sources, of course, today their contribution to energy, global energy usage in our economy has the same value as oil, coal, and natural gas, but in a decade, this contribution should be twice higher, and at the final point where we expect the most of our results of our efforts in the middle of the century, these contributions should be 80 even more percent in comparison to total energy usage. Everything concerned and the aviation sector. So aviation sector should be prepared for these changes in energy usage. Our aircraft, our aviation infrastructure, everything should work with new sources of the energy. And you see, once again, if to look globally on a fleet, it is very different independent to purposes which this aircraft must reach in their transportation work. Even I included in this list urban air mobility, very innovative part of air traffic system. Currently, it is started. In some cases, it is working even, for example, for transportation, in particular for medical issues. Drones are used to transport very important cargo, very urgent cargo to places which difficult to be reached by road traffic because of very big and very how to say problemed issues. So not talking about passenger for EAM today, but you see aviation system is big now, and everything should be developed in a sustainable way to include in mind what changes we expect and how these changes provide for us opportunity to reach the main goal. In accordance to this situation, 2 years ago, Clean Aviation Joint Undertaking was started in Europe, in aviation sector of the Europe, and this new program will be organized during the current decade. And the main goal of this program to provide new aircraft designs with new aircraft propulsion, and which should be much more efficient for fuel burn use, and to provide new energy sources for this aircraft, which need to be sustainable, not fossil fuels should be used. They should be eliminated as much as possible. The main idea that new aircraft designs which are expected in aviation sector of the Europe at the end of the decade, they mostly for regional traffic. So I mean that new main ideas which concerned about the sustainable change in our aviation infrastructure, they concerned about quite small aircraft, not the biggest ones, but this small aircraft must show that everything is feasible. So it means that electrification of our thrust of the aircraft, that new fuels, not fossil fuels, also working. And you see, Project EFACA, which we involved in Horizon program, currently they working about two types of the aircraft. One with hybrid propulsion. It means that electrical motor included in propulsion system, and second aircraft about which we are working is hydrogen fuel gas turbines. So hydrogen should be equipped completely on the board of the aircraft, and gas turbines of this aircraft must be fueled completely by hydrogen, liquid hydrogen fuel. These two types of the aircraft which we work on in the FACA project, they are designed by Ukrainian manufacturers. For aircraft, responsibility is on Antonov Design Bureau, and for a new engine is responsibility for Ivchenko Progress. In first situation for hybrid electrical propulsion aircraft, the new engine will be absolutely new, and 25% of the thrust will be produced by electrical motor, which also designed by Ukrainian manufacturers in accordance to the requirements provided by our concept. For the second aircraft, it will be with capacity very similar to Airbus 320, but you know 320 is an aircraft for middle range traffic. But taking in mind the specific performances of liquid hydrogen used for fueling the engine, this liquid hydrogen needs for much bigger spaces to be on board for the flight, and we eliminate the distances of this flight by regional distances, not higher than 2,000 kilometers. Not only Ukrainians, of course, working on this design and principles for fuel cell, which will be used on hybrid electric propulsion aircraft. Braunschweig University is responsible to provide, and for liquid hydrogen systems and direct hydrogen consumption by engines. Polytechnica from Milano is involved to provide the technical and new scientific ideas for that. Of course, we try at once to provide necessary modelings and assessments to show that efficiency of the new aircraft for fuel burn and for emission will be reached. And for that, we designed in collaboration between Polish and Ukrainian partners involved in IFACA project, so-called Valdes platform. What it means, Valdes platform? It means that we produced a modeling space inside which we may provide the assessment of fuel burn, emission, and noise for vehicle in accordance to current ICAO standards for airport scenario and for global fleet scenarios. So efficiency should be assessed at all these important 3 levels of assessment. So for that, Valdes platform designed and used for both aircraft designs, for hybrid and for liquid hydrogen aircraft. And you see, for example, that for fuel burn and NOx emission assessment, how during the flight, in accordance to every segment, important segment of this flight, we have assessed the efficiency of reference aircraft for hybrid propulsion aircraft. It is reference aircraft today, ATR 72-600. And efficiency, you see, in fuel burn, we may reach around 20, even 25%, and for NOx even more. It means that we expect for really very efficient new aircraft in 5-10 years of this design. But at once again, I repeat, both aircraft, they completely inside the regional air traffic of the European aviation system. And today, this regional air traffic, in accordance to our assessment, only 5% of the total air traffic in Europe. Maybe 20-30 years ago, this contribution was around 15-20%, and you see from diagram on the left bottom. But low cost has changed the game during the last 2 decades in air traffic, you know, and they dominantly work with single aircraft type, and mostly aircraft type which very similar or Airbus 320 or Boeing 737. So these aircraft types dominates in air fleet, and this very important issue for assessment of regional and global aspects. For this aircraft, of course, very important to show that efficiency, burn efficiency, fuel burn efficiency, and CO2 emission efficiency reduction changed during the decades, but last 5-10 years, we did not expect big changes Only in few years we may expect that new aircraft engine designs with high bypass ratio will be introduced in operation, and only after that we may say, yes, we are going forward with reduction of this fuel burn necessary for the flight, for the thrust produced, and so on. But of course, efficiency of fuel burn reduction and emission reduction, it is not only the problem for new engines, it is a problem how to produce less weight for the aircraft, or to produce less drag for the aircraft, or high lift for the aircraft, and so on. So all these issues are also subject for new investigation in Clean Aviation Program. And in our aircraft designs, we also try to use new ideas for these very important contributors in design and flight operation. But, of course, main contribution we expect from the new fuels. You maybe know that in European Union Refuel EU program also exists, and this program is accompanied with new European law. And this law, of course, first of all, consider conventional aviation fuel to be used, to be certified for the flight. But in a company to this conventional fuel, hydrogen fuel also provided, and sustainable aviation fuels of various kind of production also included, and all of them should be certified for new aircraft designs. And the difference between them is well shown on this picture. You see, of course, the emission from the SAF, from the sustainable fuel, very similar to emission of the conventional fuel, but the carbon which is produced inside this emission for SAF, it is used from the biomass or other types of products used in technology production for these sustainable fuels. For conventional fuels, the carbon is from the earth, so it is a new contribution to our atmosphere, to biosphere. SAF is using the carbon from biosphere and return this carbon to biosphere. But even today, we consider the possibility how to capture this carbon. And you see, if this carbon will be captured by technology during usage in the flight, the emission will be reduced maybe 4 or 5 times higher than it is compared to usual combustion currently. But of course, the new technologies should be used for SAF production. You see today very new values for the costs. SAF, sustainable aviation fuel, 3 times higher cost than for conventional fuel. It's the fuel produced from the biomass, but a number of other synthetic aviation fuels also exist today, which even may be 10 times higher cost than the conventional fuel. So it is a challenge which should be solved in this decade to make the prices for SAF and for conventional fuel more or less equal. In such situation, the implementation of the SAF will be efficient. For that, of course, as I said, a law for sustainable aviation fuel exists. In accordance to this law, even today, we must provide around 2% of the usage of SAF in aviation sector. At the end of the decade, you see on the diagram on the right, it should be in European region around 6%. It does not mean that all the aircraft must use completely the SAF. Today, every aircraft, maybe you know, maybe not, every aircraft is certified, has a certificate for usage of so-called blended fuel. Blended, it means mixture of SAF with conventional up to 50% for any component. And till the end of the decade, every aircraft should be certified for 100% usage of SAF. It means that it will be a possibility to provide legal issue of usage of completely SAF fuel in aviation sector. What is a big advantage of sustainable aviation fuel in comparison with hydrogen, for example? It means that existing infrastructure completely the same as for conventional. You understand, because the performances of the SAF are absolutely the same. Very small differences, of course, exist, but infrastructure necessary for aviation fuel, sustainable fuel, absolutely the same. So we do not need the improvements, we do not need the investments for these improvements in infrastructure. Big advantage that SAF production needs for new investments, not only directly in infrastructure in airports. Big investments are expected for SAF production, for new technologies production, and so on. And all these issues, once again, they are included in European law for refuel the not only aviation, but all transportation sector in European Union. And in accordance to this law, first of all, we must work about rising contribution of the SAF with decades up to maybe not 100, but very close to 100 of SAF usage in aviation sector at 2050. But also the how to say equal possibilities for conventional fossil fuels and SAF in accordance to their costs. And trading system, European trading system or global aviation trading system, which is called CORSIA, must influence in this situation. But first of all, if, of course, the sources, the feedstocks for the SAF will exist, and availability of these feedstocks and the possibilities of these feedstocks will be enough. You see that we have the global map of the capacity of SAF in the world, not only, once again, not only for aviation sector, So today, as I understand, around 10 feedstocks really certified or very close to final point of certification for aviation sector. If to look directly on Europe, you see that during this decade we expect that in reality 6% about which I said before at the end of the decade should be provided. Feedstock exists and technology for these feedstocks certified, and production centers for these technologies are designed at the moment, and they will provide the availability of the SAF during the decade and following two decades in amount which we expect to have. For all these feedstocks, the life cycle assessment of the emission was estimated, and these estimations are used by Corsia, by trading scheme for aviation, and these estimations are important for taxing any feedstock, taxing any fuel to be used for aviation sector and so on. As you see, not only in Europe, in the United States also, and first of all, maybe in the United States, every day we have the comparison. What are the prices between conventional fuel and sustainable fuel? And you see in experience main picture in the center, it's the data from Argus in Los Angeles company, which provided for you the everyday data for prices. And you see in United States, even today, for aviation purposes, the price for SAF only twice, if I said before 3 times higher, but today in specific areas even twice higher than a conventional fuel. So it is very important. And in Europe, responsible for that EASA, Agency for Safety, which also working on subjects on environment protection. They provided the current prices in Europe for SAF and for conventional fuel. And of course, a few words about the carbon prices and taxation of the fuels.
Professor Zabortovich, sorry, please.
I am finishing, I understand. It's a finish. It's a final point.
Thank you so much.
So prices will be equalized by taxation. And of course, main conclusion, we are working on new designs. We expect new designs will be much more efficient, but you must understand, the main sector will be obliged to work with SAF, because only SAF, around 60–70% of contribution to reduce carbon emission, it is obligation for SAF usage in our experience. Thank you very much for your attention, and little bit higher time I used. Sorry for that. It's a finish. Thank you very much.
Thank you so much, Professor. It is very, very, in fact, this is we discussed together about the maritime application, the fuel, considering that biofuel and typically the sustainable aviation fuels, the same application. Maybe, do you have any question there, audience? Please, Dr. Tolunay, speech is yours.
Thank you. I think you hear me.
Yes, I hear.
Okay. First of all, I would like to thank you for valuable presentation, Professor. Thank you very much.
Thank you.
I have always a question in my mind, not regarding with the increasing the efficiency, but the process, how to produce that much of hydrogen. If we use conventional hydrocarbon-based fuels or renewable energy, will it work to survive the civilization from source crisis? Thank you.
I understand your question. Of course, if to take in mind even market issues and market mostly influencing on prices, market mostly influencing on how the new fuels will be implemented, I am very sure this influence will be not enough. So, from my opinion, really only administrative influence or in accordance to law about which I said, or in accordance to any other administration or trading effort, it will be done. But you are quite sure, and you are quite right, that availability of hydrogen fuel or of any kind of sustainable fuel at the moment is very eliminated. We need, first of all, very big investments for that. And I am not talking at the moment about how much they are big and from where they should be used. But assessments made by scientific and commercial community show that possibility exists, and these values which I presented in my talk today, they are supported by assessments made by scientific community. But once again, of course, I'm still how to say, try to be not so brave. I try to be a little bit quiet with our steps forward. It concerns aircraft designs and it concerns fuel types, new fuel types to be used for aviation sector in particular. So everything is evident on the paper, but not everything is evident in life. This is my answer.
Thank you, Professor.
Thank you.
Thank you for the presentation, Professor, again. Thank you so much. Dear participants, we want to invite another speaker, the Professor Mikhail Sherman from the Tomsk State University, and speech about the fluid flow and heat transfer in the heat pipes, numerical simulations and application. The professor in here? Yes. Yeah, welcome, Professor. Thank you for accepting our invitation.
Thank you, Professor, for your kind presentation. Dear colleagues, first of all, I would like to thank organizers for an opportunity to present this report. The title of my report is The Fluid Flow and Heat Transfer in Heat Pipes, Numerical Simulation and Applications, and some words about outline. First of all, I would like to introduce briefly some words about heat pipes, physical structure of heat pipes, and applications. And taking into account that nowadays the development of different engineering devices, different apparatus demand a usage of CFD or digital twins. Therefore, the main objective of my presentation will be about mathematical modeling of fluid flow and heat transfer in the considered subjects. And as a result, during the second part of my presentation, I'll tell you about 2D and 3D mathematical models that can be used for simulation of fluid flow and heat transfer in cylindrical cavities, taking into account that it is possible to use heat pipes of different configurations, and my report will deal with cylindrical wicked heat pipes as for cylindrical cavities as the main geometry of such a heat pipe should be analyzed from the fluid flow and heat transfer aspect. And sure, taking into account that I will analyze the a wicked heat pipe, it means that it is necessary to analyze the fluid flow and heat transfer in porous media. Therefore, during the third part, I'll tell you about mathematical models that can be used for analysis of fluid flow and heat transfer in porous material. And sure, I'll tell you about some aspects concerning numerical simulation, concerning solution of the obtained governing equations using CFD. And sure, it is necessary to highlight three levels that can be used for correct analysis of the physical processes. And taking into account that the considered mathematical models were developed using in-house codes. Therefore, it is necessary to tell about verification and validation. And sure, I'll tell you about some benchmark problems that can be used for verification of the developed in-house codes. And finally, I'll conclude. Some words about heat pipes. Briefly, as you know, heat pipe is a heat transfer device that employs phase transition to transfer heat between two solid interfaces. A heat pipe is a structure with very high thermal conductivity that enables the transportation of heat whilst maintaining almost uniform temperature along its heated and cooled sections. In general, heat pipes are passive thermal transfer devices able to transport large amounts of heat over relatively long distances with no moving parts using phase change phenomena and vapor diffusion. The main structure of a heat pipe consists of an evacuated tube partially filled with a working fluid that exists in both liquid and vapor phases. Here you can find a picture of the application of heat pipe for the electronics cooling. And on the right picture, you can find the cross-section of heat pipe. It is a wicked heat pipe. It means that we have a porous medium inside this heat pipe. And as for physical structure of heat pipes are constructed of metal pipes made of copper, aluminum, or other metals with high thermal conductivity, sealed inside which is a small amount of liquid known as a working fluid. It can be pure water or other liquids, and a capillary structure like a wick. And at the same time, it is possible to say about wicked heat pipe and wickless heat pipe. The second one is well known like a thermosiphon. But here I would like to tell about wicked heat pipes. It means that we should analyze the following structure. It is the scheme of the considered heat pipe. It is possible to find two ends of heat pipe. The left one, it is the evaporation zone, and the right one, it is the condensation zone. Therefore, then one end of the heat pipe is contacted with the heat source, its working fluid evaporates, absorbing latent heat in the process, and the resulting vapor in the central part moves to the low temperature section of the pipe. In this case, it is the right side. And the working fluid in this area with a relatively low temperature condenses, releasing the heat and returns to the liquid form. Therefore, in the right part, in the condensation zone, we have the condensation of the vapor into the liquid, and as a result, during the capillary action, it is possible to obtain the return flow of the liquid to the evaporation zone. And this system requires neither power nor maintenance and it can operate for a long period of time. As for applications of heat pipes, it is possible to analyze different scenarios like shown here. First of all, for heat transfer applications where efficient heat transfer with small temperature differences is the primary purpose, it should be noted that, for example, for classical cylindrical wicked heat pipe, the temperature difference inside the heat pipe is about between 2 and 5 degrees. Therefore, it is possible to use such an efficient heat transfer mechanism for different processes, for different engineering systems. Also, it is possible to use in the case of isosomal applications, where reduction of the pre-existing temperature gradients of a body and operation with isosomal surfaces is the primary purpose. Also for the temperature control applications where the heat pipe controls the temperature of a body, and for the heat flux transformation applications where heat from a high heat flux at the evaporator is transformed to a low heat flux at the condenser. Here you can find the types of the heat pipes based on the construction. It is possible to analyze cylindrical, rotating, loop, variable conductance, and pulsating heat pipes. And my presentation from a mathematical point of view will be about the first type, about the cylindrical heat pipes. And as for different applications, here you can find, I think, not all, but maybe more important fields, including electronics cooling, geothermal systems, nuclear systems, waste heat recovery, space technology, building thermal comfort, and solar thermal systems. And further on, I would like to discuss with you a possibility to use the different mathematical models that can be used for analysis of fluid flow and heat transfer in cylindrical cavities, taking into account that the considered geometry is a cylinder. Therefore, from a mathematical point of view, it is more convenient to use the cylindrical coordinates, and here you can find the governing equations that can be used for description of fluid flow and heat transfer in the vapor zone in the central part of the cylindrical heat pipe. But in the case of axisymmetric, it is 2D mathematical model, and as you know from nature or engineering point of view, it will be more physically and will be more accurately to use 3D analysis, but it is too time consuming. Therefore, it is possible to think about 2D simulation, and I would like to tell you about 2D models also here. And as a result, here you can find the classical Navier-Stokes equations that can be formulated in cylindrical coordinates. The first one is the continuity equation. The second and third it is motion equations and energy equation. Taking into account that the wicked heat pipe, for wicked heat pipes, it is not necessary to analyze the effect of gravity force, or effect of this force is not essential. But in the case of wickless heat pipes like thermosiphon, it is necessary to analyze an effect of Buoyancy force. Therefore, for general formulation, here we included an effect of the Buoyancy force, and this effect can be found on the right side of the motion equation number 3 using the Boussinesq approximation. And sure, these equations were formulated using the temperature independence for the thermal properties of the considered working fluid, but also it is possible to include in a mathematical model also dependencies on temperature. And from numerical point of view, the main difficulties that can be found with solution of such equations is a lack of equation for the pressure. And as a result, as you know, from usage of finite volume method or finite difference method, it is possible to use some artificial techniques. If you would like to use finite volume method, it is possible to use simple like algorithm, and as a result, at each time step, taking into account that this problem is time dependent, therefore, at each time step, it is necessary for us to use the global iteration in order to define the correct pressure field and velocity field. Therefore, for the time-dependent problems, such an application or such a technology can be more time-consuming, and we would like to think about maybe more effective approach for numerical simulation. And in this case, it is possible to do. It is possible to exclude the pressure at the first step from analysis. It doesn't mean that it is impossible for us to analyze the pressure field. It is possible to do, but for the first step, we can analyze only heat transfer and hydrodynamics, and after that, it is possible to define the pressure field. And for this purpose, you can analyze non-primitive variables in the case of axis-symmetric fluid flow, or in the case of 2D mathematical model. The definition of non-primitive variables can be found in this slide. It is stream function and verticity. We have a very good relation between stream function psi and verticity components, and a very good relation between velocity components and verticity. And using these new functions, new variables like stream function and verticity, it is possible to obtain the identical view of the continuity equation, like shown here. What does it mean? It means that the mass conservation law is satisfied identically. And as you know, from numerical point of view, it is very important if our different schemes, if our numerical technique allows to obtain the satisfaction for the conservation laws for mass, momentum, and energy. And in this case, an introduction of such non-primitive variables allows to obtain such a satisfaction. Therefore, it is a very good approach. But from another side, the continuity equation doesn't allow for us to obtain an equation between stream function and verticity. But we can obtain such an equation using the definition of verticity, like shown here, taking into account a relation between stream function and velocity components. It is possible to extract the following equation, like shown here. It is an elliptical equation for the stream function. And as a result, it is possible for us to rewrite initial classical Navier-Stokes equations, like shown here. Initially, we had 4 equations using mentioned above non-primitive variables, and the resulting equations can be found here. As a result, we have only 3 equations. The first one, it is the elliptic equation for the stream function. The second one, it is the parabolic equation for the verticity, and also we have the energy equation. It should be noted that these equations were formulated using non-dimensional parameters, and the definition of these parameters can be found here. From numerical or physical point of view, here you can find some non-dimensional numbers like Prandtl number and Rayleigh number, and it is possible to analyze the fluid flow in the considered domain of interest under an effect of these numbers. And taking into account that we consider the confined domain of interest, it means it is necessary for us to introduce the boundary conditions. And as for boundary conditions, it is possible to use the classical values for the stream function at the border. The solid wall stream function has a constant value, and very often this constant is equal to 0. And also it is possible to use no-slip conditions like the second view of this condition for the same function. And this condition, I mean the second form of this condition for the stream function, should be used for definition of the verticity at the solid wall. And initially, from differential point of view, verticity can be obtained using the relation between verticity and stream function. More detailed description of these mentioned aspects can be found in our published papers shown here. The formulated boundary value problem can be solved using finite difference method or finite volume method. Also, it is possible to use the lattice Boltzmann technique. But in our lab, we used finite difference method for the solution of this system of partial differential governing equations. And it should be noted that we use finite difference method of the second order of accuracy. For example, for an approximation of convective terms, we use the monotonic Samarsky scheme of the second order of accuracy. For an approximation of diffusive terms, we use the central differences. And also it should be noted that for solution of 2D problem, and this formulation is for 2D problem, for solution of this problem, we use the locally one-dimensional Samarsky scheme. And the main idea of this scheme is a reduction of 2D or 3D problems to the system of 1D problem. Therefore, it is very comfortable to use such a technique because for solution of 1D problem, it is possible to use the effective classical technique for solution of the system of equations. I mean the system of linear algebraic equations. And it was about 2D mathematical model and about axisymmetric fluid flow. But in general, it is very useful to analyze the formulation of the considered phenomenon in 3D, taking into account an effect of all three coordinates and time also, if you would like to analyze the evolution of flow structures and thermal patterns. Therefore, it is necessary to think about an application of governing equations for 3D case. And here you can find also Navier-Stokes equations for 3D case, but using the cylindrical coordinates, like shown here. And as a result, it is necessary for us to solve 5 equations. Initially, we have 5 equations, and also here you can find an effect of Bjornsted force taking into account the Boussinesq approximation. And also, it is possible to find the same problem. I mean, we don't have the equation for the pressure, therefore, we have some problems concerning the definition of pressure field. And taking into account the classical approach from finite volume method, it is possible to use some techniques that allows to define the correct pressure and velocity fields. But it takes a lot of time for numerical simulation, as I have said above, for the time-dependent problems. Therefore, we think maybe it is possible to use the same primitive variables, non-primitive variables, sorry. But as you know, in 3D, it is impossible to use stream function. Stream function is absent in 3D case, but it is possible to introduce another function, another vector function that can be considered like similar to the stream function. And here we decided to use the following functions. It is the vector potential functions shown here. We have the special conditions like divergence of psi is equal to 0, and we have a very good relation between the velocity field and vector potential functions. And also we decided to use the modified verticity vector. It is not the classical verticity vector that is equal to curl of velocity vector. We have some modification for extraction, maybe more comfortable equations for analysis. Therefore, we decided to define the verticity vector components like shown here. And more detailed analysis can be found in our published paper. And as a result, it is necessary for us to rewrite these 5 equations to the new form. And it is necessary for us to solve the following 7 equations. the first three equations for the velocity vector components. Also, we have three equations for the vector potential functions, equations number 16, and the energy equation. All equations were formulated in non-dimensional form. And as a result, you can ask me, what is the advantage of this technique? Because initially we should solve for only 5 equations, but finally, after such a transformation, we should solve 7 equations. It is a very good question because it seems that we don't have some advantages concerning such technique. But taking into account that we say about time-dependent problem, it means that it is necessary for us to analyze evolution of the flow structures and heat transfer patterns. At each time step, we should define the velocity field, temperature field. And as you know, using finite volume method and primitive variables, this technique is well known and well spread in different commercial software like COMSOL, Fluent, and so on. And as you know, for each time step, it is necessary to use the global iteration. It means that the computational time can be essential. But in our case, for analysis of time-dependent problem, it is not necessary to use the global iteration because initially we excluded the pressure from analysis, and it is not necessary to analyze the correct pressure field and velocity field. But from another side, sure, it is necessary to add to these 7 equations one more equation for the pressure. It is the elliptic equation. But finally, it is possible to essentially decrease the computational time. We use such a technique for solution of different convective problems concerning natural convection in 3D case, convective radiative heat transfer also in 3D case, convection with an effect of rotation, convection with phase changes using the phase change materials, and so on. And in comparison, quantitative problems, in comparison with the usage of finite volume method and primitive variables, we have shown that it is possible to essentially decrease the computational time. Therefore, we can use such an approach for analysis of fluid flow and heat transfer in 3D case, in our case in 3D cylindrical cavity. But another problem it is the formulation of boundary conditions. Here you can find boundary conditions for the vector potential functions and verticity vector components. As for verticity vector, it is not a problem taking into account a good relation between verticity and velocity. Therefore, from physical point of view, it is not difficult for us to define the velocity values at the wall, maybe motionless or movable wall. And using these values, it is possible to define the values of verticity vector components. But as for vector potential functions, it is a problem because initially this function is an artificial function. And from a mathematical point of view, it is possible to use such classical conditions like shown here. And as for another boundary, I mean borders for 0 values of phi and 2p for phi, it is possible to use the periodicity conditions. Here you can find these conditions for the first components of the vector potential functions and verticity vector component. And the same condition should be used for other components also. And as a result, the formulated boundary value problem also can be solved using the finite difference method, and we use this technique for solution of this boundary value problem with finite difference schemes of the second order of accuracy. And our numerical technique for 3D case is similar to the mentioned above in the case of axisymmetric fluid flow in cylinder. And further on, we should analyze the possible mathematical models that can be used for description of fluid flow and heat transfer in porous media, taking into account that the subject of our analysis is fluid flow and heat transfer in cylindrical wicked heat sink. Heat pipe, sorry. Therefore, it is necessary for us to analyze fluid flow not only in the vapor cavity in the central vapor core, but also it is necessary to analyze the liquid flow through the wick. Therefore, it can be considered like a porous material. It is necessary to think about correct models for analysis of fluid flow in porous material. First of all, I would like to analyze possible approaches for analysis of heat transfer in porous material or heat transport in porous material. It is possible to use two different approaches. The first one is a local thermal equilibrium approach, and this approach means that it is necessary for us to use only one energy equation. It means that the temperature of fluid and the temperature of solid matrix of porous material are the same, and we don't have differences between these temperatures. But from a physical point of view, it is very often it is not so, taking into account that the process is not so rapid, and as a result, we have some differences between the mentioned temperatures. I mean, temperature of the fluid and temperature of the solid matrix. Therefore, it is necessary to use the second approach. It is a local thermal non-equilibrium model. As for the first approach, local thermal equilibrium model, it is not difficult. We should have the following equation. It is the energy equation, but it is necessary for us to use the special correlations for the effective parameters like shown here. It is the volumetric heat capacity and thermal conductivity, taking into account the porosity. Epsilon is the porosity of porous material. And we should use the thermal properties of solid matrix and of fluid for the volumetric heat capacity and thermal conductivity also. As for local thermal non-equilibrium approach, it is necessary for us to solve two equations. The first one for the solid matrix, temperature of the solid matrix, and the second one for the fluid flow. As a result, on the right side of these equations, you can find the last term, and here we have the difference between temperatures, temperature of fluid and of liquid, and temperature of solid matrix. Taking into account that this difference is not equal to zero, therefore it is necessary to solve these two equations like a system of equations. And another problem, it is the definition of the heat transfer coefficient. H here is the heat transfer coefficient, and we should use some approaches or different models for definition of this parameter. Here you can find possible approach for definition of heat transfer coefficient in the case of porous bed particles. But from another side, it is possible to use other approaches that can be found in some published papers. And here we should define heat transfer coefficient taking into account the specific surface area, like shown here, and the fluid to solid Nusselt number that can be defined based on the Prandtl and Reynolds number, but Reynolds number also based on the particle diameter, like shown here. And using these equations, as a result, it is possible for us to solve or to define the fluid flow and heat transfer in the central part of the heat pipe, I mean in the vapor cavity. And also it is possible to define the fluid flow and heat transfer inside the wick, inside the porous material. Finally, it is a complicated system of equations. It is possible to solve these equations using the mentioned techniques. And taking into account that for solution of this problem, we can use our developed in-house codes. Therefore, we should think about the different steps or different levels that should be performed for numerical simulation. And before these levels, I would like to tell you also about the definition of velocity patterns and firstly, velocity patterns for the fluid flow through the porous material. Previously, we analyzed possible assumptions for analysis of heat transfer in porous material, but also it is necessary to add to the above mentioned equations some equations for analysis of fluid flow. And here we decided to use the averaged model. It means that initially we use the Navier-Stokes equations with some additional terms taking into account an effect of porous matrix. And here you can find the most general. Yes.
Professor, sorry, be collected, please.
Sorry. Yes, please. Maybe 1 or 2 minutes. Thank you.
Yeah.
And as a result, it is necessary to use the following equation number 2 and equation number 3. It is motion equations, and on the right part, you can find the additional Darcy terms and for Jaeger terms. As a result, we should have the Darcy-Brinkman for Jaeger model for description of the fluid flow inside the porous material. And taking into account these equations, in combination with the energy equation for the porous material, with combination with the mathematical model for the central vapor cavity, it is possible to solve the mentioned equation using the considered numerical technique. As for CFD, here I would like to highlight an application different levels. The first step, it is the real world. The second step, it is a mathematical model. And the third step, it is a computer model. And we have some transition between different models. The first step, it is the qualification. It depends on our understanding on the considered problem phenomena. The second step, it is the verification. It means that it is necessary for us to verify the computer code and to analyze the relation between the computer code and mathematical model. And the final step, it is validation. It means that it is necessary for us to validate our computer code to compare our results with experimental data. And for the verification, here you can find some benchmark problems that can be used for the developed in-house codes. For first of all, the first problem, it is a natural convection in a vertical differentially heated cylinder. Here you can find a very good agreement for the steam lines and isotherms for different values of Rayleigh number. The second benchmark problem was about natural convection in a gap between two isothermal coaxial horizontal cylinders. But this agreement can tell us only about the quality. But as for quantity, here you can find a very good agreement for the values of the average Nusselt number for the second benchmark. And the third benchmark concerning the natural convection in a differentially heated partially porous square cavity. Also, we can find a very good agreement with numerical data of other authors. And as a result, it is possible to use the developed numerical technique for simulation of the considered fluid flow and heat transfer in the cylindrical cavities with porous layers, and as a result for analysis of the cylindrical wicked heat pipe. As for conclusion, here you can find the main points concerning the mentioned parts of the presentation about the brief description of heat pipes, about 2D and 3D mathematical models, and also models for analysis of fluid flow and heat transfer in porous material, about 3 levels of computational fluid dynamics, and some benchmark problems that should be used for verification and validation of the developed in-house code. Thank you very much for your kind attention, and if you have any questions, you're welcome.
Thank you, Professor. Thank you. Very good presentation about it's very critical mathematical solutions of the process. The audience, do you have any question? Thank you, Professor. Again, thank you so much. Thank you for your invitation, exceptional invitation. The other speakers, Andrei Voit, Head of the Global Public Industry Affair, Communication, Danfoss Climate Solution. the speech about the public affairs, sustainability, Danfoss climate solution. Andre in here?
Yes, I'm here, but the speech is about competitive. Yeah.
I am so sorry for time.
That's okay. I will have to be a bit fast then, because unfortunately I will have to step out at 35. So I will try to do my best to go through the presentation.
Professor Michael, please close the your presentation, Professor.
Yes, just a moment.
Thank you so much.
Do you see my slide?
Yes.
No, I don't see it.
Stage is yours, Andrea.
It doesn't. Do you see the right presentation?
Yes, but presentation mode is not.
You see it in presentation mode or not?
Yes.
Yeah, okay, good. Okay, so my presentation is going to be about competitive decarbonization as an opportunity for industry. My name is Andrea Vogt, and I'm heading the Department for Global Public Affairs, Sustainability and Communication in Danfoss Climate Solutions. And I hope this works now. Okay. So 2 words, just very briefly about Danfoss. Danfoss is a global company with a global footprint, but headquartered in Denmark with very deep roots in Denmark, still family owned. We have over 39,000 employees worldwide and global sales of 9.7 billion euro. Danfoss is structured into 3 segments, power solutions, climate solutions, and power electronics and drives. I belong to the climate solutions segment, which is about heating and cooling. I'm going to skip this one, just to see, as you see, the 3 business segments are relatively evenly spread. So, to the topic of this presentation, I wanted to highlight the opportunities that come with competitive decarbonization, as it can create value and competitive advantage for industry. There are basically 3 very important pillars here, which the first one is based on energy efficiency as a critical lever, and also as a very cost-effective opportunity to drive decarbonization. Then electrification, which is a very strong trend that we see everywhere in the world, and which is increasingly important also to decarbonize industries. And then sector integration and sector coupling. And here, for example, waste heat is a very interesting opportunity. If I'm putting numbers on this, then we have, for example, the very striking fact that if there were variable speed drives applied throughout in European industry, then we could achieve cost savings of 22.6 billion euros. We also have this huge potential of 37% of the EU's industrial process heat that could be met by heat pumps, and we are still quite far from tapping into this potential. And then the huge opportunity that comes with excess heat. So, coming back on what I said earlier, we have these 3 opportunities: increasing efficiency. I just highlighted the vast potential of variable speed drives. Then the second point on electrification, and here heat pumps are really crucial. They can achieve a lot also in industry. We tend to think heat pumps only about residential purposes, but there is much more that heat pumps can do, specifically when it comes to electrification of process heat. And then the reuse of excess heat, which can be done directly in the facilities where excess heat occurs, or if there is a district energy network nearby, it can also be linked to district energy networks, of course. This is just another graph showing the massive potential of heat pumps in the electrification of process heat. And interestingly, over 1/3 of this process heat can immediately be electrified because the technology is really standard. Up to 100 degrees, definitely, and even up to 200 degrees, there are very little barriers. So we can tap into this potential immediately. So now I wanted to show very quickly case in practice, specifically here our Danfoss factory in Poland. In this factory, we produce components that are used for indoor heating and cooling. The factory itself has 3 halls with 82 production lines, and it is a quite big footprint with 37,400 square meters. So the decarbonization was quite an in-depth undertaking with a new hall and also retrofit of the 2 old halls of the factory. So number 1, increasing energy efficiency. I was talking about variable speed drives earlier. So here, variable speed drives played a very important role in reducing the energy consumption. And also the fact that simply switching off machines when they are not in use was achieving massive savings. So this is one important lever if we want to increase energy efficiency. There are, of course, many other levers as well, like building automation and control systems, thermal controls, etc., when it comes to increasing energy efficiency. Now my presentation is stuck. Then the electrification lever, as I was saying, very important when it comes to decarbonizing industries. And here, in this specific case of our factory, we installed 2 air-to-water heat pumps with a scope of 3.8 to be used for heat in winter and to support the cooling in summer. Interestingly here, we also combine with the reuse of excess heat, which is recovered from compressors, chillers, and production stations in the operations. So that's also where the sector integration is really interesting. As I was saying, in this factory, we also integrate and reuse energy that is already around. So here the waste heat. In this specific case, in our factory in Poland, there were 2 new air handling units that were installed, 1 existing that was refurbished, and the recovered heat, waste heat, is reused for air and water heating purposes in other parts of the buildings. And I would add, this is the example of our Polish factory, but we do have a very similar example of our headquarter in Norborg, which is actually carbon neutral already since 2022, where we applied exactly these steps as well. We reduced the energy consumption a lot, also with the thermal controls there. Then we made sure that we reuse the excess heat, for example, from production processes and from cooling. And as a third step, we resourced renewable energy, for example, with solar panels. So it's something that can be really applied in, I would say, those steps can be applied in whatever industrial sites or parts of it in any case. So there is a massive potential here that we can use immediately. Here, in this specific case, we achieved 1.8 million kilowatt-hour savings per year, both on electricity and gas, massive cost reductions in terms of the energy bill, and altogether a payback time of less than 2.5 years, which is, of course, really important if you want to make sure that those measures are implemented. I wanted to bring very briefly another case, which is not Danfoss case, but where we collaborated very closely. It's a brewery in the Netherlands called the Gulpener Brewery. And here, the beauty of such a process is that in a brewery, you both need heating and cooling. And traditionally, those processes are disconnected. So traditionally, you would have a cooling unit separate from very often fossil fuel boilers to achieve the required process heat. So there was a real opportunity here to connect these two temperatures, if I can say so the cooling and the heating system, when they started to refurbish their facilities. And so in the process, 3 heat pumps were installed in 2024 with a capacity of 500 kilowatt together. And also the cooling system was refurbished with a system using hydrocarbons. So we have here a great example where not only we could phase out the fossil fuel boilers, but also we could bring in the heat pumps, couple the heating and the cooling processes, and on top of that use natural refrigerants, in this case then the hydrocarbons. So preliminary results, but this is still ongoing, is a savings of natural gas of 75%, massive. So altogether, as I was saying, we need to incentivize the electrification, and here the electricity to gas price ratio is very important, obviously. We need to incentivize waste heat recovery, where we could, for example, have EU-wide guidelines. Could you please shut off your microphone? I don't know who's talking, but you have your mic open. Thank you.
Andrea, sorry, I closed.
Okay, thank you. And then, so second, we have waste heat recovery, where we could, for example, develop EU-wide guidelines for the implementation of waste heat recovery in other regions of the world. Of course, this is also very valid with guidelines, incentives as well, maybe even obligations to act if there are opportunities, if heat mapping is being undertaken, etc. And then the focus on flexibility is very useful as well, of course, because it will support the phasing of renewable energies. So key takeaways, we have existing solutions, we can use those solutions immediately, and they are very cost effective also for the industries that may use it. We should electrify wherever possible, and again, the technologies are absolutely available, and we should not think in silos, but integrate sectors wherever possible, specifically also if we have simultaneous heating and cooling needs at the same facility. There's a huge opportunity to use waste heat directly on site or feed it into district energy if it is around. And that's it. Thank you very much. And unfortunately, I do have only very little time for questions. If you have any, then please.
Thank you. Thank you, Andrea. Thank you. Very good information about the sectoral application. Okay, the audience, do you have any question? One question for Andrea here. Andrea, one question for me. What do you think about, that artificial intelligence is very critical for sectoral process? How the transition, how the effects of the downforce, the product use the artificial intelligence?
I think first of all, if you talk, so there are different aspects to the artificial intelligence. So first of all, Danfoss proposes, for example, software solutions very much based on artificial intelligence to control heating of buildings. We have a software which is called Lean Heat, and which, for example, uses weather data, forecasts, etc., to ensure that the heating systems in the buildings are running according to the needs. So that is a direct application of Danfoss technologies for using artificial intelligence to optimize energy use, increase energy efficiency, and achieve cost savings and energy savings by doing so. So that's one thing. The other thing I think which is interesting to mention in this respect is that the increased use of artificial intelligence generally, of course, also increases the need for data centers. And so there we have a real opportunity, I would say, to integrate the data centers into the energy systems and also to make sure that they are as energy efficient as possible. And there again, Danfoss offers quite a lot of opportunities, also cooperating with OEMs and other suppliers to ensure that we increase the energy efficiency in data centers. And here, waste heat recovery is one very important lever because, of course, there is a lot of waste heat available generated by the servers and the cooling systems. So that waste heat can be used, for example, with district energy to heat nearby houses or office buildings or whatever is in the region. And then also the whole technology of direct-to-chip liquid cooling, which is emerging as one of the leading technologies in that sense, and where Danfoss is very much present also with solutions to support that technology. I don't know if that answered your question.
Thank you. Yes, thank you. I think that is a very critical subject for futures for all the sectoral stakeholders. We discussed together about the for futures, university, and sectoral applications, the same process. Okay, the audience, do you have any question, another question for Andrea? No question. Thank you, Andrea. Thank you for your support. Thank you for your contributions of the ISEMAS 2025. We will see you in next in 2026. See you. Bye.
Thank you. Thank you so much. Yeah, thank you.
Thank you. Dear participants, first of all, thank you the another speaker, but Professor Sergey Boychenko from the National Technical University of Ukraine, but isn't here because he said he was currently in the shelter and they had received a bomb alert. That's why he wasn't connected for this one. The other invited speaker, that is Professor Serhat Burmoğlu from the Katip Çelebi University, but isn't here. But the other speaker, the Dr. Oktay Çetin, here.
Yes, I'm here.
Yes, stage is yours, Dr. Oktay.
Thank you, Professor. Could you release permission for my presentation?
Yes. You have permission.
Could you see my slides?
No. One minute. Yes. No. We don't see your slides. Please share again. Please open the computer, your presentation. After that, share it.
No, it is open. I'm trying.
Dr. Çetin, please first of all open your in your desk your presentation. Next, yes, next select the share link. Select your screen or your presentation from here. If you have a problem, please
Wait for a while, please.
The Serhat, Dr. Oktay, the invited speaker, the Serhat Burmoğlu here. If no problem for you, I want to give the speech. His about Serhat Burmoğlu. No problem. Thank you so much. Serhat Burmoğlu here. Yeah. Professor.
Hello.
Hello. Please.
Hello, everyone.
Stage is yours, Professor. If you have any, if you have the presentation, please share it.
Yeah, I will open it. I will open it now. I want to give permission for sharing my screen.
Yeah.
And I think you can see my screen. Is that right?
Yeah, I don't see it.
Oh, I'm sorry. Checking it now. Let's do it again.
That is okay. We can see.
You can see now?
Yes, Professor. We can see. Your sharing is okay.
You see, but we don't see it. Sorry, 1 minute.
Can you see now? Now, following the symposium from Northern Cyprus, and that is okay. I can see your sharing, dear professor. Okay. If everybody can see, maybe they can listen to. If they couldn't see. But right now it is not in the screen. Well, it disappeared. I think it is separately. And let's make it full screen. Can you see now? No, not yet. Yeah.
Professor, share again, please, from your computer.
Okay, I'm trying now.
Try it now. Please open the share.
Include sounds, contents.
First of all, you see that from here, share the screen or window, no problem. But
yeah, I'm giving the permission for Teams. It's okay now. And I'm sharing window. I think it is trying to recording the screen, and so I should give a permission for that. But now it is not. Even I'm giving the permission, it is not working with them.
we give you the permission about it. We don't problem because
It says we need permission to share your screen. Go to security and privacy and screen recording to give permission and start sharing. And now I'm going there and system audio recording only. It says. And
Professor, close open the again, please.
okay, I will try it.
Please.
Unfortunately, it is not doing that thing. If you want, I can verbally explain or present my presentation, if it is okay for you.
Okay, no problem.
Okay. So, my name is Serhat Ulmoğlu. Actually, I will present you today on sustainability issue, especially from the perspective of industrial symbiosis. And this is one ongoing study of mine. And the name is From Barriers to Solutions, Analyzing Patent Responses to Industrial Symbiosis Implementation Challenge. In this project, in this paper, actually, we try to bridge the gap between circular economy theory and industrial practice through comprehensive patent analysis. So we look to the patent analysis, we examine them, and then we try to understand what is happening and how industry respond to different challenges in this. And first of all, we have to maybe remind the definition of industrial symbiosis. We know that it is a collaborative approach where waste outputs from one industrial process become valuable inputs for another and creating closed-loop sustainable industrial ecosystem. We know that it has a great sustainability potential, especially for waste reduction, resource efficiency, and also energy optimization and carbon footprint reduction, which is very important nowadays, especially because of the Green Deal process, and circular economy implementation and industrial decoupling from virgin materials. We have successful examples, especially they are very big examples like Kalundborg in Denmark, Vinana in Australia, and Chinese eco-industrial parks. But we know that it is not a widespread thing because there are implementation challenges like limited waste adoption, despite decades of research on this industrial symbiosis thing, and there's a gap between theoretical promise and practical realization, and multiple interconnected barriers to implementation and need for systemic solutions. So the critical question here is, why hasn't substantial research translated into widespread sustainable industrial practice? For this issue, we try to understand how do patents contribute to addressing industrial symbiosis implementation challenges and barriers. In this barrier thing, we try to understand how patents respond to different barrier categories like technical, economic, regulatory, social, and informational knowledge. We know that patents mostly respond, especially the technical and technological response. But we try to understand these patents, how respond these technological response to industrial symbiosis, and we want to systematically understand how formal technological innovation responds to documented IS information industrial symbiosis barriers remains absent from literature. So we go to the Landsat.org global patent database, and then we process the text by using Python libraries like NLTK, and then we apply cyber embeddings, and then we apply piece clustering and piece 2,000 patents for this issue, and we try to understand the temporal evolution from 1976 to 2025. At the end, we find that there is an inflection point, especially acceleration following Kyoto Protocol, and then the recent growth between 2019 to 2024, 160 to 200 patents annually. And we saw that there is a Western dominance, especially from US 97.7, and limited emerging economy, China only 1.8%, and technology transfer concerns. And we saw that there is a strong protection, especially large patent families indicate high perceived value, and there's a market interest. We saw growth rate for 3 or 5 multiplied general patenting rates, and innovation investments, particularly substantial R&D directed industrial symbiosis channels. And we saw that, as we expected, 79.6% of patents focus on technical solutions, while economic viability 4% and regulatory frameworks 2.2%. And we can see that even there's a technical rush, we saw that there's a system imbalance. Innovation concentrates on readily patentable solutions, but there's an implementation gap, especially because of the non-technical barriers remain unaddressed by formal R&D. And at the end, we find that mostly symbiotic biological systems, plant growth systems, waste treatment technologies, and monitoring and control systems are taking part as technological reply for industrial symbiosis solutions. And we saw that energy and carbon management, water treatment, digital systems, agricultural symbiosis, and materials applications with different numbers of patents stayed in this ecosystem. We saw that social barriers has 8.2% volume, but getting high citations received. So we saw that for technical barriers, they are cited averagely 8.91, but social barrier studies, they get citations with 43.33 average. And it shows that because mostly patents are prepared for creating a solution for technical point of view, but if we try to focus on most social barriers and information barriers, it seems that they have more citations, they have more diffusion and impact. So, in this case, economic viability, regulatory facilitation, social coordination, and geographic bias, mostly the critical implementation gaps we identified. And for solution, we prefer new patterns should be a combination of technical and economic, or social and digital, or regulatory and information. So, comprehensive innovation portfolios addressing full spectrum of implementation barriers for forward pathing. And in this case, we saw that there's an innovation misalignment and value volume paradox and biological dominance. Even there are need for different industrial symbiosis problems to solve by technical community. I think it is very short and impactful, maybe, thing for you.
Professor, if you want, you can send me your presentation. I open from here.
Yeah. I can send it now. I can send now. It is actually HTML document. So I should give you. Could you reach that?
Sorry, from the mail?
By using the WhatsApp, I try to find
WhatsApp, okay. Oh, I open it. I open it.
But
okay, I open it in here.
You can open it? Okay. Okay.
No. Please send me PowerPoints. And here only HTML problem.
I don't have a PowerPoint version, but I can send it later.
1 minute, 1 minute. I open it. Okay. Okay, I open it. Yeah.
Okay.
This is, you see that in here?
Yes.
How slides, Professor?
Now I couldn't see it. Actually, I couldn't see your screen.
Ah.
Oh, yeah. Now we are at the end of these slides.
End of the slide.
Yeah.
This one, completion.
Yeah. So, in this case, we can see that beyond technological or technical patents, even patents are responding this issue mostly, but with biological dominance. We have to go forward by using more social informational and maybe organizational barriers we have to put in these patents as a solution for maybe engaging more industrial partners in industrial symbiosis process, because most companies suffering from regulatory issues or sometimes organizational resistance because of some resistance from the management or some workers and other people. And so we have to deal with them by using patents with combination of these kind of problems. And thank you very much for your listening. If you have a question, I can explain or I can answer it.
Thank you, Professor. Thank you again for good presentation. I think it's a very critical subject for symbiosis, especially for industrial application. Do you have any question, dear participants? I have a short question about it. How to discuss together with, that circular economic application, considering that waste management. About it, symbiosis is a very critical subject. We're considering that together, the waste management. What do you think about it?
Actually, circular economy is an umbrella thing, and so industrial symbiosis is a part of that. And so, if we try to apply circular economy in industrial context, it is a little bit understood by industrial symbiosis thing, because there are different applications which industries or industrial zones now applying it and successfully doing this symbiosis thing. But we have to focus on not only technical thing, or it is not only a waste management thing, because in this case we don't try to understand industrial symbiosis as only a waste management, but actually we have to understand we try to use the waste or make waste a valuable thing in the system. So we have to think a little bit broader, I think.
Maybe we discuss together about organizing industrial zone areas. About it, we manage the waste and the symbiosis together, especially the valued material critical points for this one. Thank you so much. Thank you for good presentation. Thank you. Thank you again. Thank you. We see that between the participants, the Professor Sergey Borichenko in here. Professor Sergio?
Yes, dear colleagues, please.
Welcome. Thank you so much.
Apologies for the absence of Professor Borichenko. I will present instead of him due to urgent matters caused by recent air raid alerts. So he's unfortunately unable to join at the scheduled time, and I will present in his place.
Yeah. Thank you.
So now I will share the presentation.
1 minute, please. Yes, Professor.
Yeah, could you see it?
Yes, I see that.
Okay. Did the slides changing?
Yes,
it's all work. Okay, thank you. So the presentation named the creation and implementation of sustainable aviation fuels, the Ukrainian vector, and recent achievements and prospects, prepared by Professor Borichenko from National Technical University of Ukraine, Interactive Laboratory for Diagnosing Operational Materials in Energy and Transport, Scientific and Technical Union of Chematologists, and Ukrainian Oil and Gas Academy. So the sustainable aviation fuels is produced from sustainable feedstocks and is very similar to its chemistry to traditional fossil jet fuels. And using SAF, sustainable aviation fuels, results in a reduction in carbon emissions compared to the traditional jet fuels. And some typical feedstocks used are cooking oils and other non-palm waste oils from animals or plants. And other potential sources include forestry waste, such as waste wood, and energy crops, including fast-growing plants and algae. In February 2022, aviation and petroleum industry leaders and the US Federal Aviation Administration announced a new initiative to phase out the use of leaded tail-containing aviation gasoline by the end of 2030 without adversely affecting the existing piston engine fleet. The initiative is called Eliminate Aviation Gasoline Lead Emissions and involved fuel manufacturers and distributors, airport operators, aircraft operators, and general aviation airport support community. So, at this slide, you can see our climatological team. And to achieve the lead-free goal, we must identify at least one unleaded fuel acceptable for safe general aviation fleet use, minimize the safety and technical impacts associated with high-performance engines using unleaded fuels, and facilitate the increased production, distribution, and the greater use of unleaded replacement fuels. A number of important steps have been taken in Ukraine with the purpose of the active introduction and use of sustainable aviation fuel in Ukraine. In particular, the Climatological Scientific School was developed the concept of the development and introduction of environmentally safe jet fuels. The Chemicalogical Scientific School has developed a draft of technical regulation for the requirements for the quality of aviation gasoline and fuel for airjet engines. And the Climatological Scientific School, which we representing, is carrying out a complex of research work on the development of new commercial formulas of alternative aviation fuels called biojet, as well as the methodology for their introduction and use in civil aviation. So, the experience and prospects of sustainable aviation fuel use in Ukraine is methyl esters of fatty acids, acyl esters of fatty acids, and bioadditives for jet fuels. No, FAME, FAEE, and bioadditives. So, the Chemicalogical Scientific School has developed a recipe, conducted laboratory and operational tests of alternative fuels called Biojet 10, Biojet 20, based on rapeseed and camelina sativa oils and ethyl alcohol. Biojet contains 10% of bioadditives and Biojet 20, respectively, 20% of bioadditives. Tests have shown full compliance with the quality requirements according to the standard STM D6055. And here we can see the philosophy and the concept of our work. And the conclusion. So, modern aviation is one of the main consumers of fuel of petroleum origin, such as aviation gasoline and fuel for jet turbine engines. The system of technical regulation in this area, as well as in the aviation fuel supply system, is imperfect, and at the moment it is in a state of reformation. The situation with the introduction of technical regulations for the requirements for aviation motor fuel has become urgent today. Implementation of the technical regulations will provide an opportunity to further management of regulation in the field of production, supply, quality control, and consumer protection. Our team developed and proposed some recipes of sustainable aviation fuel for jet engines of the code brands Biojet 10, Biojet 20, Biojet 30, and also unleaded gasoline 100 UL. We developed the concept of the development and introduction of environmentally safe jet fuels and unleaded in 100 UL with full compliance to current standards. Thank you for your attention.
Thank you, Professor. It is very difficult for you to, I understand. Thank you so much for your contribution. Okay, the participants, the other speaker, Dr. Oktay Çetin in here, yeah?
Yes, I'm here. Let me
please try again. If you leave the problem, I share problem here. The Professor, Dr. Çetin, I open from here, no problem.
Okay, I sent you.
You see that in here, my share, the Dr. Çetin?
Yes, yes.
No problem here.
I can see it.
Yeah.
Our topic is assessments of decarbonization impact and environmental cost index for ships. Please go on. Outline is on the slides. Now I'm going to talk about the motivation for our study. This study evaluates the environmental impacts of cargo ship energy consumption using an entropy-based approach. We got all the data from a company located in Istanbul. First, it examines the entropy potential associated with exergy efficiency in ships, particularly the impact potential of exergy destruction. By integrating sustainable economy criteria, I will talk about this issue later, the manageability of entropy potential in ships under recyclable conditions has been examined and evaluated. Next slide, please. Within fossil fuel-based consumption framework, uncontrolled pollution resulting from system problems, operational deficiencies, and technological inadequacies leads to significant economic and environmental losses. There are some processes which become important drivers in achieving the IMO's towards net zero emissions from shipping 2050 vision. And economic demands have also been an important driving force, particularly in the management of decarbonization. Within this scope, the study provides support for decarbonization strategies in the maritime sector's operational processes for ships. Now on the slide, you see a previous work made by Professor Sörgüt and me. The issue is environmental cost index. Sustainable energy management in the shipping sector will reduce fuel costs as well as operating costs. In this way, economic evaluation criteria, which can be applied to each ship, can be developed. And we explain this issue as environmental cost index. Next slide, please. In this slide, you see our previous work. It is a flow diagram of energy efficiency strategy for ships. Next, please. Now we are shifting another issue, decarbonization index. We need some results to be calculated. In order to achieve this, it has been established a formula. Now I'm going to explain this formula. The decarbonization index developed by Surgut provides a manageable tool for enterprises to explore possible strategies, and the decarbonization index, which produces a reversibility-related boundary condition, especially for real processes, can also be used as a model to support the development of possible opportunities, and the index developed for this purpose is on the slide. In this study, a model was developed based on 100 key data points from a ro-ro ship operating between Pendik, Turkey and Trieste, Italy. The ship's load values and performance were examined directly under full load conditions. In the modeling, irreversibilities, viscous flows, and thermal effects that would affect the ship's sustainability under steady-state conditions were neglected. Next. Energy and exergy analysis and distributions related to the ship's main load parameter evaluated in this context, and these information are presented in figure 2. On the left-hand side, the blue one, I mean, you see average energy efficiency, which is approximately 38%. On the other hand, average exergy efficiency is 35%. Next, please. And these analyses have shown that voyages of average energy efficiency in the previous slide were around 38%, and the average exergy efficiency 35%. The potential for losses arising from irreversibility in environmental conditions is shaped by exergy destruction. These values cause exergy destruction due to fossil fuel consumption on board ships. So in this issue, in the conclusion section, I will explain some offers. Next one, please. This potential was evaluated directly with exergy input on the ship, and the distributions are shown in this slide. The blue one, it shows us the exergy, and the red one shows exergy destruction. Next, please. In the analysis conducted, the environmental impact of exergy destruction is particularly significant. In this integrated structure, exergy destruction is a viscous effect resulting from irreversibilities. Indeed, the potential of exergy destruction when fuel consumption is evaluated indicates an average potential of approximately 75%. This load distribution is an important point in terms of energy management opportunities directly related to irreversibilities. Next, please. This point is related to the improvement rate value developed by Van Gogh in thermodynamic terms. This value is important for determining the possible boundary conditions of conversion in energy management. Next. In this study, the improvement rate distributions for each voyage developed as a form of exergy destruction are presented on the slide. And the IP rate potential distribution is between 35 and 47%. Next. And IP shows that there is potential for a structure to support energy manageability and operational improvements, especially on ships. And in the concluding remarks, I will explain this issue again. Next, please. In this study, 2 environmental impact indices were also evaluated based on these values. These impact indices are the Environmental Performance Index and Sustainability Index values, respectively. The Environmental Performance Index value is the environmental impact ratio caused by the entropy produced under actual conditions together with the environmental conditions. On the other hand, the Sustainability Index value represents the expected pollution limit condition of the ship under directly reversible conditions. In the analysis conducted, the average environmental performance index was found to be 0.65, while the average sustainability index value was 0.24. Next, please. The 2 parametric values proposed in the study were analyzed for these conditions, and both environmental impact assessments and decarbonization potential for these conditions were examined. Environmental cost impact, which was developed in 2021, can be seen as a cost impact for corporate structures in terms of energy losses. However, the decarbonization index, which was put forward by Professor Sogut, defines the potential of energy input that needs to be eliminated in terms of direct fossil fuel potential. Next, please. When both parametric data are examined, parallelism is observed in terms of cost and decarbonization processes. In the slide, you see that the impact of these distributions on each voyage made by the ship separately. Next, please. The average environmental cost index for the defined voyages was found to be 0.42, while the average decarbonization index was 0.53. These values can be seen as the decarbonization potential for energy conversion in ships. From an improvement perspective, these values also define the environmental dimension of the fossil fuel threats. Next. Now I'm going to shift to concluding remarks. This study presents a model that supports the environmental sustainability of energy on board ships and investigates the effects of potential consumption of existing fossil fuel sources. Within this framework, impact analyses were conducted using the voyage data of a RORA ship over 100 voyages based on the proposed decarbonization index and environmental cost index parameters. Next, the study identified potential improvements alongside current consumption behaviors, and in this context, the exergy efficiency of the ship's current consumption was found to be 35% on average, and the IP ratio based on the ship's fossil fuel consumption behavior was determined to be 42%, and the environmental cost index value of the ship was found to be 0.42 on average, and this value can also be evaluated as a ratio of potential loss in terms of cost. The ship's decarbonization index ratio has been defined as an average of 0.53. This value should be considered as the decarbonization target for the ship's fossil fuel consumption. Next, please. The decarbonization approach presented in the study is a model developed to address the definitional challenges associated with the current emission factors of ships and to assess pollution directly based on entropy. The study may offer a new perspective that supports environmental sustainability in conjunction with life cycle assessments. Next, here are our references. 2 slides, one more, and this concludes.
Thank you for your presentation, Dr. Oktay. Dear audience, do you have any question? No question. Thank you so much. Thank you, Dr. Oktay. Thank you for your contributions. And the other speaker, the Tolunay Kaya Arasi, a study on energy management and sustainability tensors, factors and parameters. Dr. Tolunay in here. Yes, Dr. Tolunay. It's okay.
Okay, hello everybody. I'd like to briefly...
50 minutes, please.
Yeah, okay. I'd like to briefly bring to your attention the well-known topic of energy, as it directly impacts the sustainability of our civilization. Unfortunately, the sustainability of human civilization is related to the energy required to produce the tremendous opportunities afforded by technology. As Maslow said, everything arises from needs, and needs are inexhaustible. However, we see that needs are constantly increasing in number. Technology readily meets these needs. Of course, the energy resources required to produce and even consume these needs are depleting at the same rate. As you know, 95% of today's energy needs are met by hydrocarbon-based fuel sources. What will happen to our civilization when these limited resources are depleted? This is the fundamental question that demands an answer. With this short study, I'll try to draw attention to the question of what awaits us and what we are dealing with. In fact, every study on energy is invaluable, but it's impossible to say the same thing about its consumption and future based on the reliable statistical data we have. Without further delay, I present my study. Motivation, method, and material, output and conclusion are the parts of my short presentation. Careless consumption of existing energy sources is the main reason motivating the presentation. Of course, all kinds of efforts, research, measures, applications, etc. are of vital importance to extend the time until new, clean energy sources are explored. Global hydrocarbon-based energy reserves consumed without regard to for future generations will be depleted within 200 years. Our energy-dependent civilization continues to consume global energy resources as if they will last thousands of years. If consumption continues at this reckless pace, talk of energy efficiency, renewable energy, and flue gas treatment will only prolong the expected end for a few more generations. Although science clearly demonstrates that this vitally important behavior is wrong, people are more concerned with the health and environmental problems caused by the flue gas emissions. Unfortunately, they are ignoring the real danger for their own personal interests. Especially in the last century, the energy consumed to generate power has been increasing in proportion to population needs and
iki kişi gelmiyor sizin şeyde.
Production rates.
Keynote'lar gelmiyor. İstiyor.
Reliable resources. Reliable, serious statistics provide scientific evidence that consumption is trending in this direction. Faced with this reality, the entire scientific community urgently needs to focus on new energy sources. Although modern science offers new ways to use energy, humankind is not aware that rapidly depleting energy resources will also mean the end of its civilization. Even setting aside their disadvantages, renewable energy sources like solar, wind, and wave energy will never be able to replace the amount of hydrocarbon-based energy currently consumed. This is clearly evident from quantitative and qualitative academic studies and research on global energy resources. It's not hard to imagine the chaos that will end human civilization, which has existed for at most 200 years. I'm sorry, it's wrong, I think here, 200 years. If new sustainable energy sources are not found. Statistical data analysis on energy production, consumption, and management show that the problem must be solved within 50 years at most. Otherwise, humanity will be dragged into a chaotic environment full of inevitable energy wars, which is already in headed silent progress. To have a sustainable civilization, our concern today should be the discovery of new clean energy sources that will yield at least the same amount of energy provided from hydrocarbon-based sources. While global renewable energy production, with its diverse characteristics, is increasing, it appears unlikely to replace hydrocarbon-based energy consumption in the coming years. While all ongoing mandatory studies on renewable energy saving, efficiency, synergy, etc., are important due to their positive and significant impact on the environment, climate, and health, the discovery of new energy sources should be at the forefront. These vital realities compel all nations to develop urgent radical solutions which should be successful in the short, medium, and long term. Many international institutions are working to resolve energy-related issues more quickly, fairly, and effectively. However, to prevent global vital energy crisis and ensure sustainable civilization, large amount of new clean energy sources must be found before the end of this century. On the other hand, it is clear in which areas of activity the relevant energy institutions are generally focused. It appears that these institutions are unable to join the focus on short, medium, and long-term solutions to the inevitable threat of global energy depletion within the framework of a single program and plan. The imperative motivation created by the reckless consumption of energy resources has highlighted the need for an international structure to exploit existing energy resources and explore new ones. Numerous rigorous theoretical, analytical, and experimental studies in the literature on energy threats have been reviewed in order of priority. It has been hypothesized that an international program encompassing potential tensors related to energy issues could be an opportunity to address these threats in a sustainable manner. A quantitative research article based on this hypothesis is currently under completion for peer review. The possibility of extending civilization depends on the success of scientific, uncompromising studies that must be established and completed successfully in the short, medium, and long term. The authority, which is expected to be organized by international consensus based on the assumption that fuel will be depleted within 50 years, is expected to complete studies, implementations, and research on energy conservation, standards, and clean energy sources within this specified time frame. Energy consumption in every area needs to be managed scientifically without considering individual, institutional, or national interests. In the short term, sustainable energy consumption requires mandatory education and discipline. In the medium term, a fully authorized independent international energy management authority is essential to ensure administrative, financial, legal, and especially technical standards based on diverse concepts and principles which cannot be left to the discretion of nations, companies, or individuals. The vital reality regarding energy today is the absolute need for new energy sources to replace what is being consumed. The time required to find and implement new clean energy sources is crucial. This issue remains open and uncertain. Establishing global standards that will cover all areas through international consensus and implementing them uncompromisingly is not easy. However, uncontrolled and irresponsible energy consumption is a vital problem that must be addressed because it is an inevitable and irreversible reality. The international authority to be established should create an algorithmic matrix and multiple correlations containing potential energy-related tensors, factors, and parameters to sustainably solve short, medium, and long-term global problems. The establishment of an international organization furnished with full uncompromising authority is essential in managing new clean energy source investigations as well as managing the existing energy resources. All studies planned by this institution for the short, medium, and long term must be successfully completed within 50 years at the latest. I would like to thank the editors for the data figure 1, 2, and 3, partially used in this presentation without having the opportunity to obtain permission. Here are the references which I used to prepare my presentation.
And
thank you for your listening.
Dr. Tomay, thank you very much for your good presentation. I think that it's a very different view for the features of the energy solution, energy problem about it. You know that in the carbonization process of the, especially depends on the fossil fuel. According to the scenario, we see that in 2100 years in fossil fuel use, approximately 38%. What do you think about for futures fuel considering that maritime?
Well, in my opinion, the hydrocarbon-based fuels will continue to be used in maritime, unless otherwise hydrogen, if produced on ships immediately, just in time, and used as an additive to the fuels, will increase the efficiency. But none of them will help the civilization end because we have only 100 years in front of us to find new energy sources enough to feed the global consumption. So only for our generation, maybe next 2 generations, we are thinking all these issues, increasing efficiency, decreasing flue gas products, or energy saving. But after 3rd generation, what shall we do? We have to think on this.
Okay, thank you so much, Dr. Tornay. Do you have any question for the audience? No question. Thank you so much.
Thank you.
Can Tuncer, you are ready for your presentation?
Yes, I can start. I can share my screen.
Yes, please share it. Please share it.
Thank you. Can you see my screen?
Yeah.
Welcome. In this presentation, I will make presentation about our study on high efficiency counter-rotating vertical axis wind turbines designed with PM generator for urban environment. I want to thank you, my colleagues, Professor Enver Yalçın, Professor Ali Oral, and Mr. Lütfi Çolak. My name is Can Tuncer. I'm working in Gateway R&D Center as R&D unit leader. I'm mechanical engineer. Our motivation on this study is, as you know, global energy consumption and demand is increasing day by day, and green policies being stronger and important. Renewable energy trends, installed capacity, and demand of renewable energy sources are increasing. This situation has increased R&D studies in renewable energy technologies, costs have been reduced, efficiency increased, renewable energy systems widespread all over the world. Capacities increased, wind and solar farms, huge wind and solar farms were established. In addition, interest in small standalone systems has increased also. One of them is vertical type wind turbines. R&D studies and scientific studies were carried out in this field. Alternative design types have emerged, efforts to increase efficiency accelerated. Okay. At this point, as GRI R&D Center, we decided to do a study on this area as a wind tower manufacturer. As an in-house R&D project, we have developed a model which produces 2 kilowatts power with 3 blades, as you see in the picture, right side. Blade and rotor design and production were developed by us. The prototype was produced, installation completed, we made the measurements, we saw that all the targets were achieved. After that, we focused on alternative concepts and we planned a new project, including deep engineering studies and research. We defined the problems, we asked questions and tried to find solutions and try to add possible innovative improvements. What were they? How can the efficiency be increased? How could we increase the best limit up to 64%? We saw that after our scientific research, counter-rotating twin rotor plus PM generator can make this capacity increase. Also, generally in wind turbine towers, they use gearboxes, and we thought that we can use direct drive. By this, low maintenance and low noise can be ensured by direct drive. Also, can wing design be idealized by aerodynamic analysis? We use QBlade program, open access QBlade program for designing and developing innovative blade forms and also rotor form. Can the electrical power produced at low wind speeds be increased? Yes, with counter-rotating twin rotor system, we can make 2 times higher rotational speed can be achieved in order to reduce starting torque for efficient energy production. After that, can the rotor structure be more compact? Yes, with actual two rotor counter rotor system, blade length could be divided to half length. Defining the concept with the mentioned needs and goals, a concept design for vertical wind turbine has emerged with an innovative twin rotor alternator operating in counter directions. As you see, upper rotates to counter and the down rotor rotates to counterclockwise. And high efficiency wing structure with helical and twisted angle occurred. Driving without transmission, direct drive method we used. And we started this design by taking 2 kilowatts and relative speed of 240 RPMs for each rotor. These were the innovative sides of this study. This is also a project in our R&D center. What we do as innovative, we tried different wing blade parameters, and we made aerodynamic analysis to idealize efficiency, increase efficiency. Then we created counter rotation to rotor like this. And also in this design, we needed to think about the concept of new alternator like this. In this alternator, there is a one stator and two rotors rotating counter clockwise and clockwise directions. Summary of the results. With this study, we developed a counter-rotate twin rotor wind turbine with high efficiency blade profiles and alternative concept with 2 intertwined rotors. By these listed improvements achieved, counter rotation doubles alternative input speed, reducing required poles. Efficiency is maintained with no significant increase in losses or change in power factor. Compact design reduces volume and material use of alternator body. DRS direct drive eliminates wear maintenance and mechanical losses. High torque can be achieved at low speed, minimizes starting problems. Low vibration and low noise are ideal for urban use by this design. Modular structure lowers production costs and allows scalable variants. Suitable for rooftop installation, microgrid, standalone energy, and smart cities. And also another positions this device can be used. Aesthetic and architectural integration is emphasized, and safety measures and regulations are needed due to high rotation speeds. When we look to the future studies, transition from concept design to realistic production design must be achieved. This is a concept design, and we plan to move this design into production, the product design. To develop the design of the alternative, we need to work together with experts on the subject, electrical engineers and academicians who are expert on this subjects. clarifying uncertainties such as energy transmission, storage, legal regulations, security must be solved. Prototype production, we will make the prototype production after this study is complete. And then we will pass to performing tests such as performance measuring, vibration, noise, climatic resistance tests. We will collect data and evaluate the results to improve the design to better positions. To present the achievements to the literature with new scientific studies after this, we will present the product to consumers in global market through market research, patent acquisitions, and mass production planning and marketing studies will be made by us. Thank you for your participation.
Thank you for your presentation, Can Tuncer. I think comments, Professor Birol Kılkış, or question?
Yes. Thank you very much, Can. This is a very good, what we call synectic design, which means thinking something which has not been tried before out of the box. And I wish you the best of luck. But I have two questions. The first one is, what is your net efficiency according to your calculations? I know you don't have the prototype yet, but what is your expected efficiency? What's your target?
Expected efficiency. I talk about the story first. When we look at the base limit, now it's 59.3%, and with contra-rotating rotor, we saw in some scientific studies it can be increased up to 64%.
And it needs some verifications, of course, but it's your target, I understand.
Yes.
And in your one of the last slides, you show multiple applications on the median of expressway. Can you go to that slide, please?
Which slide, sorry?
Many applications on the road.
Okay. Last one.
Yes, this one. This is a good idea. This is practice, but actually one of the problems that are not considered is the fact that if you put these low enough or lower than the optimum height, it mainly gets energy from the bypassing trucks and cars, which generate an additional resistance to the trucks and the cars. So therefore the fuel efficiency is decreased. So there is a careful optimization problem there. How much electricity you get or power you get from your wind turbines there, and how much efficiency loss and therefore fuel spending increase is related. If you make them high enough, of course the cost is increasing, but then you eliminate this problem and you get the wind effect from the nature, not from the trucks. So there's an optimum height depending upon the type of the road, the location, etc. So this is not an easy problem. It's just a comment that the height and the pitch, so the spacing is very important on the overall energy savings and carbon dioxide emission reduction. So I should like you to recommend you that this might be a very good research and simulation issue or an R&D case for you, and just tackle that problem, please. Thank you.
Thank you, sir. You are right. We haven't focused on getting energy from trucks or from traffic. We only focused on taking energy from nature, from wind. But I will consider this. Thank you very much. Also, another problem for these systems, for these installations is safety. This is very risky. Like you in our first design, it looks dangerous actually. We need to focus on safety also if we will use this in urban areas like this, as I mentioned in my last results slide.
Thank you. Have a good day.
Thank you, sir.
Thank you so much, John, for the presentation. Thank you for your comments and for your contribution to Professor Birol Kılkış.
My pleasure.
Okay, the other presenter here that Dr. Mehmet Akman.
Yes.
Stage is yours.
Thank you very much, Professor.
Quartz greener shipping on ORC waste heat recovery system using the low GWP fluids for the methanol fuels marine engine. Very special subject. I think that maybe the Professor Kılkış had many different comments in here. For us, it is very critical. You know that we studies on the green ships.
Yes.
Together, yeah. And here, stage is yours.
Thank you very much. Can you see my screen, by the way?
Yes. Presentation mode, please. Open the presentation mode.
Okay. I think you can see my presentation right now, right?
No, no problem. No problem.
All right.
All right, no problem.
Okay, let me introduce myself first. I'm Mehmet Akman. I'm working as lecturer at the Department of Marine Engineering in İzmir Katip Çelebi University. I'm also happy to be here as a former member of Peter Davis University. We are a group of researchers here and focusing on green technologies on board ships. And within the project supported by our university, I will present my initial results for this way. Here is my presentation plan. I will start with the background motivation of our study, and I will introduce methodology and our waste heat recovery system. Then I will finish results and discussion and concluding remarks.
Sorry, your slides are not moving.
I'm not moving. Oh. So let me do it again.
I think it's an issue, a general issue of the broadband availability of your system.
Maybe I can switch it to the PDF mode.
Okay.
Let's try it again. This one is the PDF mode.
Yes.
Okay. What about this? Is the slide slowing?
Not yet, but we can see the first. Yes. Motivation.
Okay, motivation. So I will start with the motivation. As of January 2023, the world fleet has over 100,000 vessels of 100 gross tons and above. In 2024, the world fleet capacity expanded at an annual rate of 2%, with overall gross tonnages hitting about 2 billion deadweight tons. So that the momentum for decarbonization in maritime industry is concerning. And this is supported by regulatory frameworks and commercial pressures. On the left-hand side, you can see the total carbon dioxide emissions by vessel types in terms of tons between 2012 to 2023, and the majority of the carbon dioxide emissions are contributed by container ships, dry bulk, and general cargo ships and tankers. On the right-hand side, you can see the world fleet, 3 main vessel types, and their monthly carbon dioxide emissions per ton mile. The trend for container ships are declining, and the tankers and the bulk and general cargo ships in the steady session. The trend for these kind of ships are steady, we can say, but the container ships are faster ships than these kind of ships. So the trend should be decreased for carbon dioxide emissions. So the maritime industry accounts for 3% of the global greenhouse gas emissions, and the emissions then reach to noticeable dimensions for the ecosystem and also the Arctic regions for this. And I put some examples for this issue. And as we know that the animals living in the Arctic regions, like the polar bears and the penguins, the population of these animals are decreasing. These are one of the symbols of actually the greenhouse gas emissions. And by the way, we are also talking about the negative effects of the global warming. And I want to point out the positive outcomes for the global warming. The Arctic shipping passage still decades away, according to the reports. On the left-hand side, you can see the predicted fastest shipping routes through the Arctic region. The red lines show the ice-breaking ships, and the green lines show the regular ships routes for the close future. As global warming continues, by 2030, routes over the North Pole could open for ice-breaking cargo ships capable of operating in ice up to 4 feet thick. On the right-hand side, after 2045, the shipping routes will be predicted to be expanded. And between these years, the decline of the Arctic sea ice under the moderate warming could allow even ordinary cargo ships to journey directly over the North Pole. And also, it is predicted that the journey times will decrease just over 22 days, and the number of routes will be increased as an outcome of the global warming. So, what about the developments in the administration side? Actually, the concrete steps were taken in 2011, and international maritime organizations put some regulations into effect. Mandatory measures and guidance have been released as Energy Efficiency Design Index and Ship Energy Efficiency Management Plan. Strategic plans have been released also to keep the to decrease the emissions by ships. And IMO wants to reduce the greenhouse gas emissions by maritime industry as of 2040 by 20%, and as of 2040, the greenhouse gas emissions by maritime industry is aimed to be decreased about 70%. And the net zero is the target as of 2050. And along with the carbon dioxide emissions, NOx and SOx emissions also are aimed to be decreased. And what about the how to comply with the limitations released by International Maritime Organization? There are various methods to comply with the limits. Optimized hull form design, reduced electricity consumption, power limitation, wind assistant propulsion, propeller optimization, speed optimization, biofueling management, and alternative fuels, along with waste heat recovery, are the measures to be applied on board ships. But the quickest way to comply with the regulations are switching to alternative fuels. So methanol. Methanol is also an alternative fuel to be used on board ships as marine fuel, because compared to heavy fuel oil, the SOx and particulate matter emissions can be decreased above 90%. And the methanol fuel engines also comply with the limits of Tier 3 limits with the selective catalytic reduction and exhaust gas recirculation systems integrated with these engines. And the max emissions can be reduced above 30%. And CO2 emissions can be decreased about 10% using this alternative fuel. And also, methanol is available globally. It has low supply and storage pressure, lower minimum ignition energy compared to LNG or LPG, However, this fuel is toxic and it creates invisible fire. Besides, in terms of design, ship design, methanol-fueled engines occupy much area than LNG or LPG fueled engines. Besides, methanol can be produced in various ways. The methanol is labeled as black, gray, blue, or green methanol. Black methanol is produced from coal, and the gray methanol is produced from natural gas. Blue methanol is produced also from solid feedstocks and natural gas, but it's integrated with the carbon capture systems. It makes it blue. And the green methanol is produced from biomass feedstocks, and it's using renewable energy sources. So because of that, it's green. But considering the methanol supply globally, the methanol production is mainly based on black methanol and gray methanol. And if you manage to produce blue or green methanol for the as a marine fuel, well-to-wake emissions for ships will be decreased remarkably. On the right-hand side, you can see the table. Compared to marine gas oil or LNG, the CO2 emissions by blue methanol can be decreased significantly. So, our motivation for this study is integrating methanol-fueled engine and waste heat recovery system, ORC waste heat recovery system. In our previous studies, we conducted some thermoeconomic analysis, thermoeconomic optimization studies for exhaust gas waste recovery by ORC. But we are trying to focus on very low grade basic heat recovery on our current research. Therefore, we are focusing for jacket cooling water. The main waste heat sources on board ships are the exhaust gas, scavenged air, jacket cooling water, lubricating oil, and incinerator waste heat. Exhaust gas and incinerator waste heat are classified in the high quality waste heat sources. Besides jacket cooling water and scavenged air, along with the lubricating oil, are considered as the low-grade waste heat sources. On the right-hand side, you can see the Sankey diagram of a two-stroke marine engine. About 5% to 10% of the fuel energy is dissipated by jacket cooling water. The majority of the waste heat is in the exhaust gas, by the way. So, the objectives of study is as follows: analyzing the jacket cooling water waste heat of methanol-fueled marine engines under various operational conditions, modeling and showing the thermodynamic performance of a marine-type ORC-based waste heat recovery system suitable for very low-grade waste heat sources like jacket cooling water on board, investigating the thermo-environmental performances of a zero ozone depleting potential and ultra-low global warming potential working fluids like RZA, I will call them the refrigerant ZA, refrigerant ZE, and refrigerant ZZ, which are the environmentally friendly alternatives to the R245FA, which is a widely used working fluid in the various sectors. Obtaining the preliminary data for future studies regarding waste heat from alternative fuel marine engines. These are our objectives for this study. And we use this methodology to obtain the results. The research questions is what are the energetic, and environmental performances of ORC, very low-grade waste heat recovery system under various engine and cycle operating conditions. And we have some input and assumptions for this study. And we obtained the dual fuel engine particles and conducted waste heat analysis using computerized engine application system. We modeled the organic Rankine cycle waste heat recovery system with MATLAB. We coded the cycle codes by integrating RefProp thermodynamic database, and we obtained the refrigerant thermodynamic properties, and then simulate the cycle. And after that, we analyzed the system thermodynamically and environmentally. We use MEPC guidelines to access to environmental assessments, and then we obtained the plots by using MATLAB, and we evaluated the results. Here is our basic model for the methanol fueled marine engine. We have the engine here. You can see the particles of the engine. The brake power of the engine is about 18 megawatts, and it's a slow-speed engine. It is the max technology is high-pressure selective catalytic reduction. It is operated in Tier 3 mode. On the right-hand side, you can see the basic diagram of the organic Rankine cycle. It uses the jacket cooling water of the main engine, and the purple lines show the refrigerant points, and we use the fresh water for cooling the refrigerant after the expander, after the turbine. And one of the important steps for organic Rankine cycle systems are selecting a suitable working fluid. We will use this working fluids for onboard simulation. So we have some regulations for these systems. The IMO regulations, SOLAS regulations, and F-gas regulations are used to filter the working fluids in terms of safety. And we also use the practices and our previous studies. These are the selected working fluid properties, as you can see on the table. And the criterion for selecting the working fluids are we try to select the working fluids which will have the global warming potential at less than 10. It will have zero ozone depleting potential. The critical temperature of the working fluid should be close to the heat source temperature, and the boiling point should be close to the heat sink temperature. It should be non-flammable or toxic. These are the properties of our refrigerants. Here are the results, the thermodynamic performance of the engine, of our simulation studies. First of all, we conducted waste heat analysis. On the left-hand side, you can see the specific gas and specific pilot oil consumption of the methanol fueled engine. In these engines, marine diesel oil is used as a pilot oil to prevent knocking and misfiring. On the right-hand side, the heat dissipation, the heat power of the jacket cooling water with respect to engine loads, it is changing between 100,000 kilowatt to 2,500 kilowatts in accordance with the engine loads. These are the simulation results. On the left-hand side, you can see the net power output by organic Rankine cycle. It depends on the evaporation pressure. We increase the cycle pressure between 200 to 1,000 kilopascal. According to the simulations, it is possible to generate about 180 kilowatt net power. And according to the simulations, refrigerant ZC and ZD are the most favorable ones in terms of thermodynamic performance. On the right-hand side, you can see the thermal efficiency of the power generation system. The red line shows the engine's thermal efficiency. According to the simulations, it is possible to increase the thermal efficiency of the power generation system about 1%, and the most efficient loads are changing between 60 to 80 maximum percent of the maximum continuous rating, according to the results. On the left-hand side, you can see the thermal efficiency of the organic Rankine cycle. According to the results, it is possible to obtain about 10% of efficiency using these kind of working fluids. Again, the same working fluids, refrigerant ZC and ZE are the most favorable ones, more favorable than the other working fluids. On the right-hand side, you see the exergy efficiency. It is possible to obtain about 50% exergy efficiency using these kind of working fluids. Higher evaporation pressure means higher energy and exergy efficiency, by the way. On the left-hand side, you can see a contour graph which shows the exergy destruction according to engine load and evaporation pressure. This contour shows us that the lower engine load and higher evaporation pressure means lower exergy destruction. So that means a higher exergy efficiency. At higher and heavy loads and low evaporation pressures, the exergy efficiency decreases. On the right-hand side, you can see the CO2 reduction, carbon dioxide emission reductions, parallel to the exergy destruction. It is possible to have the carbon dioxide reduction is obtained maximum at the low engine loads and the high operation pressures because of the optimal cycle conditions. So the concluding remarks, even though the emission factor of methanol is less than the half of the marine diesel oil, methanol-fueled engines have higher fuel consumption than MDO-fueled engines based on the methanol's lower specific energy content. Therefore, to decrease the carbon footprint of methanol-fueled engines, ORC integrated waste heat recovery systems can be a promising solution. The results reveal that refrigerants ZC and ZZ, both with very low global warming potential, offer a promising balance between thermodynamic performance and environmental benefits. Assuming an annual operation time of 6,000 hours for a merchant ship equipped with these systems, it is possible to avoid between 339 and 508 tons of CO2 emissions when operating at 50% to 75% MCR. The use of these alternatives can enhance the power generation system's thermal efficiency by over 1%. Instead of using R245FA, a commonly used working fluid, the proposed alternatives can be employed in onboard low-grade ORC applications. Future research could expand the scope of this study to include thermoeconomic optimization of these emerging refrigerants. More experimental studies are needed for a better understanding of the fluid behavior used in the cycle, component design, and cycle performance. These are the references, and thank you very much for listening.
Dr. Mehmet, I think it is very, very special. We discussed together about it because, especially on methanol application, I think that it is very difficult performance, difficult applications, and considering that low heat value of this process, and considering that the combustion impact of the methanol is not easy. But first question or comments from the Professor Bilal Kulkuş. Stage is yours, Professor.
Thank you. And actually, this is a very interesting and very timely presentation. Especially, I was pleased to see terms like exergy destruction. Congratulations, and I hope that you will continue on the second law of thermodynamics. I have two questions, but the first one, which is more important to ask, is it's very nice to hear that you relate the exergy destructions to carbon dioxide emission responsibilities. How did you do that? What kind of equations do you use, or what's your general principle in doing that? How do you relate them?
Yeah, actually, when calculating carbon dioxide emissions, we use MEPC guidelines. We use the carbon dioxide factor, and you know that the ORC produce net power, mechanical power, and the net power corresponds to a fuel consumption. So we relate them. We multiplied them with the carbon dioxide factor, and we calculated the reduction, CO2 reduction supplied by ORC system.
Actually, your calculations could be more favorable if you also include the exergy destruction. I understand now that the exergy destruction is not directly related to the carbon dioxide emission responsibility, because every exergy destruction means you have to offset it by someone, somewhere, and this might involve some fossil fuel. So this is another component which I think should be included. And yesterday's presentations, I have mentioned that, but it's a good work, and actually you have underestimated the advantages, so you should add the delta CO2, what we say, directly related to the exergy distractions, or minimizing the exergy distractions. And the second one, maybe related to this, is what did you consider the waste heat of ORC? Because although this is a low exergy source, it is still an energy source. And maybe you can find in ships some applications, even adsorption, which are too bulky, maybe not feasible, but even you may generate an additional cold generation, which is useful in ships. So what did you consider about the waste heat of the ORC?
Okay. Professor, actually, we conducted many analyses using the exhaust gas, using the exhaust gas, because it is more thermoeconomically feasible, because it is a high quality waste heat source, actually. But in our first study, we tried to focus on very low grade waste heat recovery and which working fluids can be applicable for these kind of systems. I also know that the energy efficiency of the ORC system is 10%, below 10%. Be aware of that. But we want to focus on very low grade waste heat recovery and find more more environmentally working fluids and combine it in the organic Rankine cycle system. The scope of the study can be expanded also.
Yes, and I suggested in other words, although low quality, low exergy, technically speaking or theoretically speaking, 90% of the input heat is wasted again. But this is at low temperature, but still you might find something. For example, you mentioned Arctic ships, ice protection, snow protection on the ship decks. It's ideal. So there are applications available for this low quality waste heat coming out of the ORC, which will actually increase again your predictions on the favorable side. So maybe this might be the second step. Thank you.
Yeah, yes, maybe. The lowest, how can I say, the low grade waste heat on board lubricating oil and jacket cooling water actually on board ships. We try to focus on jacket cooling water in this study.
That's true. I am not talking about it. I am talking about the organic Rankine cycle. The Rankine cycle generates electricity at 10%, but the rest is waste heat out of the Rankine cycle only. I am not talking about the other ones.
Professor, I want to add something on this issue. Actually, we are expanding the model. It is just a part of the model, the organic Rankine cycle, integrated with the jacket cooling water, but there is a freshwater generator below it. Actually, we use the jacket cooling water for generating fresh water from seawater on board ships. The rest of the heat can be evaluated using organic Rankine cycle. I didn't mention about this, but thank you very much for the contribution. This is a part of the whole system actually on the study.
Very good. Thank you.
Thank you.
Maybe one comment or the question from the Dr. Murat Sönmez.
Thank you, dear President. And also, Birol Hocam, it's quite nice for me to see you again. Hello. Mehmet Hocam, thank you so much for your detailed analysis and the important topic. But as I understood, your analysis all achieved in virtual environment. It is simulation. Well, I wonder whether in your university or the university of your colleagues found an ORC system, organic Rankine plant, to test for validation or verification purpose, whether the waste heat from exhaust gases could be recovered in that order. Do you have such a system? Thank you.
Thank you very much, Professor. Maybe this is the weakness of our contribution. we are trying to, no, there is no small plant to validate our results. We are just validating the results from the previous studies, validating the model and results actually. But we are planning to write a TÜBİTAK project or other projects to establish a model, an experimental model to validate our simulation results here. As far as I know, except of Boğaziçi University, there is no such plans in our country. But we, as I mentioned in the concluding remarks, we need more experimental studies for these kind of results.
Dear Hocam, I'm working for a while the Northern Cyprus campus of Middle East Technical University. In our campus, we have such a system. Well, it is capacities in the order of, as I remember, 15 kilowatts. Who knows, in future, we may work in cooperation. You're welcome.
It will be an honor for us. Thank you very much.
Thank you, Hocam. Thank you.
Murat, Mehmet, I think that the critical points, ORC process, it is not easy managed considering that for cheap applications, because the construction problem, we think that it is a very big problem, construction problem. But in here, according to these or studies related to for cooling process, provide 42% of the energy efficiency rates, considering that control process of the ships, especially these studies. We made a study on the alternative full use of the process, considering that methanol. I think that it is a big problem from that low heat volume of the methanol. It is very low.
Yeah.
Considering that diesel. What do you think about for sectoral applications of the methanol preference?
Thank you, Professor. I see methanol as the quickest way to comply with the regulations, because as we meet some sector, we talk about the people from the sectors, the engine manufacturers, as you know, Professor Ziya Suud. They share their order book, engine order book, and the engine order book says that the majority of the orders are based on methanol fuel, dual fuel engines, multi-fuel engines. So maritime industry is planning to pass this decade, maybe 2 or 3 decades, with alternative fuel engines like LNG or methanol, because these fuels comply with the regulations. These are the quickest way. They comply with SOx regulations by integrating exhaust gas recirculation systems or selective catalytic reduction, integrating with these systems to these alternative fuel engines. They comply with also the NOx regulations. So the net zero targets can be achieved by using dual fuel engines, also another systems, by integrating another systems like waste heat recovery, wind turbine propulsion, outcome optimization. So these should be a combined method to comply with these regulations. But methanol fuel engines are a little bit different, because methanol is widely available around the world. It can be produced from fossil fuels also. And the lower heat content is the biggest problem. As I shared in the results slides, the fuel consumption of methanol fuel engines is about 3 times higher than marine diesel engines. Diesel oils, actually. So there is a potential here to recover more waste heat for these engines. We actually conducted a study and compared the thermoeconomic performance of the organic vacuum cycle systems integrated with fuels, alternative fuels, and we found that organic ranking cycle systems can be more thermoeconomically feasible for methanol fuel engines compared to LNG or other fuels. So this is the point. It's true, methanol fuel engines consumes more fuel, but they also generate a bit more waste heat compared to other alternative fuel engines.
Yes, but maybe give us the contributions, the Professor Birol Kılkış, about it. According to those studies, especially the methanol use produce the big irreversibility of the combustion engine, internal combustion engine, and not easy take performance from this process. I think that produce the big irreversibility and produce the generation, the big entropy process. According to those study, for example, not good idea for solutions in methanol and as an alternative for the process. Yes, Professor Kılkış. Professor Kılkış? Yeah, microphone is closed.
The primary objective of us engineers must be to minimize the waste heat at the first hand. So, to me, to have a bigger waste heat or more waste heat cannot be a good justification for organic ranking cycle application and the engine that is considered. The first thing that we should look at is what is our waste heat, and we have to minimize it first. And the system that minimizes the waste heat must be prioritized rather than prioritizing another system with a larger waste heat, because waste heat recovery and its use efficiency is less than 1. So in this second step, we are actually reducing the input exergy of the fuel or the actual exergy usage. So the steps must be shortened, and that shortened step must look for minimum waste heat, not maximum waste heat.
Yeah, I agree.
But
these are the results that we are focusing on.
No, but this is a very informative presentation. Thank you so much. But this opened up this good discussion, and it should be a very valuable discussion. Thank you.
Thank you very much.
Okay, thank you so much. Again, I think we discussed together about for features the critical subject. I think that in here we discussed together. Okay, last presenter, Enes Günaltı in here. Enes? Do you hear me, Enes? Okay, last presenter, I give short break from this. Enes, in here. Okay, the participant will start again in the 15-hour p.m. I give the short break in here. Thank you so much. Please stay in this here. We start again in the 15 p.m. Thank you so much. Welcome again. And here we have two keynote speakers in this session. First, keynote speaker, Professor Can Özgür Çolpan, I can hear.
Hello.
Hello, Professor. Welcome. Thank you so much. Thank you for your contributions about our ISEMAS 2025.
Thank you for the invitation.
Thank you. Are you ready? If you have
Yes.
ready, please, stage is yours.
Okay, thank you. Okay.
Yes, we
Good
see.
afternoon,
We see
everyone.
you.
Thank you, Professor Söğüt, for the invitation for this conference. So, the talk of my presentation is techno-economic analysis of green hydrogen production. And I will basically talk about the ways of producing hydrogen, and I will present two case studies that we conducted. So let's start with the general introduction and why hydrogen energy is important. So as all you know, currently there is an increasing energy demand in the world, and the population is also increasing in parallel to the developing technology. Due to this, air pollution and global warming are the common problems, as all we know, and fossil fuel reserves are decreasing, and there is an energy security problem. And currently, energy supply is mainly dependent on fossil fuels. So, due to these environmental problems, many countries now put zero emission targets, including Turkey. So, in order to achieve that zero emission, there are several steps that need to be taken. And the first one is clean energy should be used. To do that, there are several ways. The most common way is increasing clean electrification, such as using electricity from wind, solar, and those kind of renewable energy technologies. And we can also produce and use clean hydrogen, which is the topic of today. And biofuel and synthetic fuel supply chains could be established. By saying synthetic fuel, mainly we mean synthetic methane, synthetic synthetic diesel, or synthetic propane, or ammonia, those kind of fuels. Most of them are produced with the combination of hydrogen and carbon monoxide or carbon dioxide, but ammonia can be produced from hydrogen and nitrogen. And carbon capture and storage technologies should be also used. And of course, less energy should be used. This will be satisfied or achieved by using more efficient equipment, processes, and manufacturing techniques. And of course, sustainable natural ecosystems are important because, let's say, sea or lakes or forests, they all absorb carbon dioxide. So we should also include sustainable natural ecosystems into the picture. Now let's move with the hydrogen energy. So why hydrogen is important? First, it is environmentally friendly fuel because there is no carbon in its structure. It's only hydrogen. So when you burn hydrogen, you obtain mainly water, which is a clean exhaust substance. Also, in periodic table, the number of the molecular weight of hydrogen is 1. So it's a light fuel. So storable fuel, we will talk about it, and it's quite reactive. And its gravimetric energy density, which is measured by megajoule per kilogram, is quite high compared to other fuels that you know, such as petroleum, natural gas. But of course, in order to use it, gravimetric energy density is not enough. Also, volumetric energy density is important. So, its volumetric energy density should be also increased by using some techniques such as compression and liquefaction. So, by compressing it to, let's say, 700 bar, we can increase its volumetric energy density like 6 times or 7 times compared to its atmospheric condition. If we even liquefy it, it's liquefied in quite low temperatures, such as
minus 350 degrees Celsius, then we can even increase this volumetric energy density more. So when we look at the hydrogen value chain, hydrogen is mainly produced today by natural gas through steam methane reforming, but this is not a sustainable way since it's using fossil fuel. So if we want to produce clean or green hydrogen, it should be mainly produced by renewable energy sources such as wind, solar. So these renewable energy technologies should produce electricity, and electricity should be fed to electrolyzer, and electrolyzer, which we are talking about water electrolyzer. So in water electrolyzer, we mainly produce hydrogen and oxygen. So then we should store this hydrogen, and it can be stored using several techniques such as compressed gas or liquefaction or metal hydride. Then it should be transported and then used. To use it, there are several potential consumers. Today, it's mainly used in refineries. But when we talk about future applications, mainly mobility will be quite important. So it can be used in passenger cars, trucks, buses, or air vehicles or ships. It can be converted into ammonia, and it can be used in agriculture. It can be used in steel industry. It can be it can be used as a reduction agent, or it can be burned and then converted into electricity and heat in green heat and power applications. So when we look at the future perspective or future outlook of hydrogen as fuel, it is considered that in 2050, in shipping, ammonia and hydrogen will have a share around 60% among all fuels, and in road transportation around 25%. In aviation, it will be used as hydrogen or synthetic fuel, and it will be around again 27-28%. And in chemicals and iron steel, it will also have a share around 25%. When we look at the EU targets, when we look at the Repower EU plan of the EU, so EU has targeted 10 million tons of renewable hydrogen production by 2020, and also they will also import another 10,000 million tons from other countries. So in total, they are aiming to have 20 million tons of production by 2030. There are also other ways of production, but as I said, electrolyzer is one of the most promising technique, but also it can be produced from biomass. So it can be converted into syngas through steam methane reforming, partial oxidation, autothermal reforming, or gasification. It can also, some biochemical conversion techniques can be used. So for example, algae from sunlight can be converted into hydrogen through biochemical conversion techniques. So there's this photograph is from Denmark, which is an energy agency in Turkey. So there are some colors that you should know about hydrogen, but the most common scheme is using green and blue. So green means that it is very, very environmental friendly production technique. For example, electrolysis of water is a green hydrogen production technique, and blue is still clean, but it is used with carbon capture. So carbon is not emitted into the atmosphere, but it is captured somewhere. So it's still very clean, but it has a different color. So now we see here the Turkey's strategies on hydrogen technologies. So Turkey has targeted to reduce the cost of green hydrogen production to less than $2.4 per kilogram hydrogen by 2035, and less than $1.2 per kilogram by 2053. And also the installed power capacity of the electrolyzer is targeted to reach 2 gigawatt in 2030 and 5 gigawatt in 2035 and 70 gigawatt in 2053. Now let's talk about our case studies. As I said, we conducted 2 case studies. In the first one, we assume that there is a wind turbine power plant in Bergamo, and the nominal power of this wind turbine power plant is 120 megawatts, and annual electricity production is around 300 gigawatt hours. So there are 46 turbines. So what we first do is to calculate the capacity factor, average capacity factor of each month. As you can see at the right, you see the results. And then we assume that, okay, now we have this electricity from wind turbine, and we want to convert some of this electricity into hydrogen. To do that, we assume that we install 10 megawatt electrolyzer into the plant, let's say. And these are other input parameters that we assume in the techno-economic analysis. So we assume, for example, the electrolyzer type is PEM. So there are 4 different electrolyzer types, but alkali, PEM, anion exchange, and solid oxide. But PEM is one of the most common ones. And we assume specific energy consumption at nominal load as 66.6 kilowatt hour per kilogram. We assume that the stack lifetime is 60,000 hours, and we assume that there is 1% degradation each year. And there are some other economical parameters also, as you can see here. So what we do, the most important parameter that should be calculated as a result of techno-economic analysis is levelized cost of hydrogen. In order to do that, of course, we need to find CAPEX, which is the capital expenditure cost, OPEX, operational expenditure costs, sale costs, and hydrogen production, amount of hydrogen production each year. R is discount rate here. So basically, we find these values for each year using some economical analysis, and then using this formulation that you see in the slide, we calculate the levelized cost. Of course, it is better to have a low value in order to have a competitive marketing target. So what we found as a result, we found that if we have 10 megawatts of electrolyzer, we will produce around 1,397 tons of hydrogen each year, and the levelized cost is $5.45 per kilogram. And payback period is important. It is around 6 years. So at the left below, you see a cumulative cash flow for a 30-year operation period lifetime. So we start with a debt, of course, but after 6 years, then we don't have any debt because we reach the payback period. And then we start to make profit. And after some time, let's say 13 years, we change the stack's lifetime is over, so we change the stack. So there's a small decrease in the cumulative cash flow. Then it starts to increase, and after some time it decreases again because of the change of the stack again. So at the right, you see the breakdown of cost components. So we see that we see the main reason of the levelized cost, why it's 5.45. We see that the main reason of having this value is the electricity purchase cost. So it means that here we assume power purchase agreements, which means that wind turbine produces electricity and it is sold to the grid, and electrolyzer gets electricity from the grid. What I'm trying to say is that if we can reduce the electricity production cost of wind turbine, we can reduce the levelized cost of hydrogen. So it's the main reason of having higher levelized cost. We also studied different electrolyzer type. At the right, you see the change of electrolyzer load with alkaline and PEM electrolyzers. So the main inputs here, PEM electrolyzer has an electrolyzer purchase cost around $1,100 per kilowatt, and alkaline electrolyzer is $750, so PEM is more expensive. But performance, when we check the performance, specific energy consumption for producing 1 kilogram of hydrogen, you have to send 67. You have to feed 67 kilowatt hour energy to the PEM, but it's lower in alkali, which is 49. And lifetime, PEM is 6,000, alkali is 8,000. So when you look at this diagram, you can think that, okay, alkali is more advantageous, but PEM also has some practical advantages, such as it can respond to changes in the electricity output more effectively. So when we see this, when we compare these two technologies, we found that if we use alkali electrolyzer, the levelized cost is lower and the payback period is lower. So this is the second case study. I will go a little quick because I have 5 minutes left. So in the second case study, we again performed a techno-economic analysis, but this time we assumed modularization of the electrolyzer system, which I will talk about it. And to do that, we assumed daisy chain allocation algorithm. And we also studied different locations, not only one location. And also we assumed not only wind, but solar, wind, or hybridization, solar wind together, for a 50 megawatt PEM water electrolyzer. So again, at the end, we again calculated the levelized cost of hydrogen. The methodology is more or less similar to the case study one. So we considered 6 different districts, which are Çeşme, Dikili, Foça, Karaburun, Seferi, Saran, Urla. And you can see the solar energy capacity factor and wind energy capacity factor for each location. So basically for solar energy capacity factor, this capacity factor changes between 24.5 to 26.1%. And for wind energy, it changes between 15% to 50%. So we assume that the system has n stacks. So, as you know, because of the changing electricity input to the system, we did modularization, which I mean that first, let's say we have n stacks. So the first stack now gets all the required electricity. If there's still more electricity, the second stack gets. If still more than the third, it goes like that. And the last stack gets the remaining. So what I'm trying to say that most of the stacks operate at nominal voltage, and the remaining stack operates at the partial load. These are the results. So we considered several hybridization ratios. So we changed solar wind ratios. For example, we found that if we have, for Çeşme, if we have a 65 megawatt wind turbine, and if you don't use solar at all, then we will get the lowest levelized cost of hydrogen. And for others, we also get some different results. For example, for Foça, we have to use 75 megawatt solar and 70 megawatt wind turbine, and then we will get $6.27 per kilogram. But more or less, levelized cost values are similar at the end. So these results also show that we don't need to hybridize for all options, but for some cases, for some districts, we can use a single technology, such as only solar or only wind. We also studied the effect of several parameters. This is called once-at-a-time sensitivity analysis. So we found that scale index is the most important or most effective parameter on the levelized cost. So we change this scale index for which gives us the price for wind turbine in this case. We change the scale index as 60, 75, and 90%, and we found the scale purchase cost. As you can see, as we increase the capacity, the purchase cost decreases significantly. So we also studied the effect of number of modules in the system. Let's say we have a 400 megawatt electrolyzer. If we use 400 modules, it means that each module is 1 megawatt. So we studied the effect of number of modules in the modular system. So we saw that after some point, there is no really change in the levelized cost. For example, in this case, it is around 80 or 90 modules. So there is no reason to use more than a specific number because the result will not change. But if you use very low modules, then we will have a high levelized cost. So here, instead of using a single or 4 or 5 modules, if you use 80, 90 modules, you can reduce the levelized cost from 6.15 to 5.62, which is quite significant. So at the end of this study, we found electricity purchase yields the highest share in the levelized cost, and we saw Çeşme offers the lowest levelized cost of hydrogen due to its superior wind capacity factor. Sizing and modularization can lower the costs. Hybrid system may not always provide economic advantages, and scale index is a critical factor for hydrogen cost reduction. And in future work, we will integrate battery to the system, and we will also use multi-criteria analysis to improve location selection. And also we will try to refine our financial models so for long-term accuracy. And thank you for your attention.
Professor Can, thank you so much for the presentation, and I think it is very detailed our presentation, considering that of use of the hydrogen and especially produced from the renewable energy. It is very critical. Thank you for a good presentation. Do you have any question, the audience, the participants? One question. We know that the production cost of the industrial application, especially considering that the hydrogen is very high. For this process, considering that use of the hydrogen in combustion process, what is your opinion? Is true or not, considering that industrial application?
Yeah, as you mentioned, producing hydrogen is quite expensive at the moment, and it's mainly because of the cost of renewable energy technologies, as I mentioned. But the main reason of using hydrogen is the environmental constraints. You're right, if you burn hydrogen to produce heat, maybe it's not very meaningful, but at the end you will have a very clean exhaust. So many applications or even countries now enforced to use clean technologies. And in order to have clean heat, it is one of the main ways to produce it. So, for example, in steel production or glass industry, you can burn fossil fuel to produce heat, but at the end you have to emit CO2 from your chimneys. So because of the restrictions or limitations now they are imposing to these industries, they have to switch, because either they will use carbon capture storage technologies or they will use some other ways. So hydrogen in this way will be a must, one of the potential ways, because there are not too many alternatives. So even it's high, they have to use it. So I think it is more than a necessity to switch to hydrogen, because they have no they don't have too many options.
Yes, it's true, Professor. I think that it is very critical subject for industrial application for features this process. Thank you so much. Thank you for your contributions for ISEMAS 2025. Thank you.
Thank you, Professor Züht. And I wish you good luck in the remaining of your conference.
Thank you so much. Okay, the participants, the other invited speaker, and Dinesh Balasubramani, and here, the professor. Yes, welcome again. Thank you for your contribution of ISEMAS 2025. Okay, please, stage is yours.
Whether I'm audible?
1 minute, please. Yes.
The screen is visible?
Yes, but not presentation mode. Yeah.
That is fine?
Yes, Professor. Yes.
Okay. Thank you very much for giving this interesting opportunity, and I'm happy to deliver an invited lecture in ISEMAS conference, and it gives me an immense pleasure. And special thanks to Oku, who has been very good friend of mine and very good. It's happy to get associated with him once again. And myself, Dinesh Balasubramanian, currently working as an assistant professor in Coastal Engineering College, Tamil India. And my topic is about advances in lithium-ion battery safety, thermal runaway mitigation, and using AI-driven prediction. So the overall agenda for the presentation is followed in this particular fashion, where we will make you to walk through the battery fire concern, lithium-ion battery in general, and what is thermal runaway, and what are the standards and regulation challenges that we currently face on, and what is the key research gap that need to be addressed. And I have I'll discuss about two interesting case studies. One is on heat transfer effect of ASEM or the thermal runaway of LIT lithium-ion batteries, and the predictive theory on thermal runaway of LITs and or related projects that I am currently working on. So this is the entire workflow of the current presentation. And moving into detail about the presentation, I'll give you some glimpse of news related to this. So 5 injured and 3 critically ill because of battery fire issue in Brooklyn. And Jaguar recalls close to 6,400 IPS electric SUV over battery fire concern. And you can see the battery fires issue that is creating on e-vehicles, and lithium-ion battery fire from electric cars, bikes, scooters on rise, and all firefighters are ready. And to handle this battery fire issue, firefighters requires an additional skill to handle this battery fire issue, and hope entire nation is focusing towards it, and all are giving an additional skill enhancement for the firefighters to handle this particular battery fire issue. So that is the reason why majority of e-vehicles are not parked underground stalls and other malls areas. So when you talk about the safety event in detail, close to 8.2 billion cells has been produced as of now, and apart from that, cell fails in the beginning itself is very minimal. That is less than 1%. And as time progresses, the issue related with safety events is lies only to the fourth digit of the decimal. So it doesn't look very big when you look at it in way, but when you look at it into a major number, this is a very big issue. So who is going to be this lucky person to get the battery fire issue will be a major threat. And talking about the battery fire concern, the decomposition of anode and the decomposition of cathode results in the high temperature generation. and followed by self-reaction with salt and solvents is also creating a major threat in battery fire issue. And talking about the temperature range, the decomposition of anode lies within a temperature range of 80 to 300, and cathode lies between 150 to 300. And when you look in detail about the energy release because of the decomposition of anode is twice as that of the cathode. So this creates a major threat about what anode or cathode is getting decomposed based on the aging parameter or other temperature rise issues. And next is that the self-reaction solved with solvent, and because of this issue, we get an higher energy release. And the another issue is the complete combustion of solvent. So it may result in higher ignition temperature close to 450 degrees Celsius, and it might result in very big temperature rise and energy release of close to 90 to 126 kilojoules. So these are the major battery fire issue concern that even one single cell might result a very big temperature rise after an unknown threat created by temperature and pressure. And talking in detail about lithium-ion battery, we need to thank Alexander Volta for his major invention of lithium-ion battery cells. And these three gentlemen play a key role in the development of lithium-ion batteries, who is Akira Yoshino and John Goodenough and Whittingham, who are Nobel Prize winners for their invention related to lithium-ion batteries. So lithium-ion batteries are not a new technology to it. Lithium is an ancient element that has been created during the first minute of Big Bang theory, where it lies close to the periodic table in the topmost portion. And the base idea is that lithium has an electron in its outermost orbit. When you're able to detach that electron and ask them to pass through a coil, that produces current. The primary issue related to this is how you are going to detach the electron from it, as lithium is highly unstable. So lithium is a weakest element and it is readily reactive, and it's also its own strength. So that is one interesting part about lithium. And this is how a basic lithium ion battery invention looks in the early stage, when you are just talking about the three great inventors of the progressive invention of lithium ion battery, where in anode and cathode side they have tried with different materials, starting with petroleum coke to cobalt oxide. And as usual, we'll have a barrier or separator followed by an electrolyte cell in between, and the ions would travel in the horizontal direction where the electrons would take the longest path. So the basic story remains the same, but the evolution plays a major role in the material progress of anode and cathode. And looking more in detail about the history of lithium-ion battery, it started with the Whittingham discovery on the earliest stage of 1920s to 50s, where he attempted with making use of anode metallic lithium and the cathode with titanium sulfate. So this is how the earlier lithium-ion batteries was initiated, which would create a close to 2 volt of power supply. But one major issue created with this, that the former of whisker generation. So you can see a clear whisker generation from the metallic lithium to the cathode side. So this created a bridging gap between anode and cathode, and it resulted in the short circuiting formation, and the battery fire was initiated. So the battery fire issue is not new issue as of now we are facing. It has been started from the earlier invention of lithium ion battery, even from the earlier stages. And moving further to Goodenough discovery, he attempted to make some changes in the basic chemistry of the lithium-ion batteries materials. Metal oxide instead of metal sulfate was introduced. Rather dealing with titanium disulfate, he just replaced this with cobalt oxide. And Goodenough started to use cobalt oxide in the lithium battery cathode. This almost doubles the battery potential and made it much more powerful. So that way we try to convert a 2-volt system to close to 4-volt system. So that was one interesting part that has been advanced in the material progress inside the battery chemistry. So that way the voltage level was enhanced. And here comes the final hero of the Nobel Prize winner, that is Akira Yoshino, who discovered where he dealt with the petroleum coke as a primary material, more or less relevant to our graphite as a primary source. and the carbon-based material to store the ion and detach back from it. So this is where these three inventors have been awarded the Nobel Prize for their invention in lithium-ion batteries. And Akira Yoshino and Goodenough plays a key role in lithium cobalt oxide in the cathode, and in anode he used carbon-based material, and which has been evolved now into the graphite as a primary source, and petroleum coke, which can also interrelate with lithium in an efficient way. And looking in detail about the working of lithium-ion battery, talking about the charging and discharging part, you will have a cathode aluminum collector and anode copper plate collector. So here the primary objective is that the lithium would be pierced inside a metal oxide. So once the plate is charged, the lithium would get detached from the composition. So that way the lithium ion would travel in the horizontal direction and the electron would take the longest path. So that is the reversible of your conversion from lithium ion to original state and electron in the reverse direction. So this is how the charging and discharging happens. But at the first time when lithium pierced to the electrolyte for the horizontal direction, it resulted in an accidental invention of the solid electrolyte interface, so which was a key advantage in the later stage of uh, electron movement in the horizontal direction. So this is an important role in the lithium-ion battery invention. And talking about the chemistries, as of now, the entire world is dealing with. They are dealing with LMO, LPF, LCO, NCA, and NMC, which talks about the various configuration of the lithium-based metal material variation within the cell, and accordingly, the performance based on the specific energy, power, lifespan, and safety plays a key role. When you look more detail into it, the lithium ferrous phosphate creates a major safety issue. That is one disadvantage when you talk in detail about the lithium ferrous phosphate, and whereas the specific energy is very minimal. And talking more in detail about the safety as an primary objective, lithium cobalt oxide is much more efficient when you just look more into the safety perspective of the battery. So in majority of cases, NCA, LMO, and LCO plays a key role in battery progress. And looking more detail into the battery chemistry packing, so it started with cell, battery, module, battery pack, and the entire battery system. So the entire battery pack or the entire battery system would not result in thermal runaway. Any one particular cell might result in a thermal runaway, and it would result in a propagation to the nearby cells. So our primary objective is to pinpoint the thermal runaway initiation and the propagation suppression is what our primary objective in this current case. So this is how block diagram can be presented in this cell component, cell battery, battery module, battery pack, and it would be monitored with an area of a BMS and the enclosure surface where the entire battery is packed. So this is how a battery pack would be looking like. And talking more about SOC, SOH, and EOL, so it depends upon the battery aging, temperature, and time as a primary factor. And EV performance perspective, in offline measurement, we will look more into the CC and CV profile of charge and discharge pattern and the driving schedule based on the different users and the data collection is gathered from current voltage and temperature and time. Talking about the future generation part that we are looking into is the data processing, health future extraction, and population degree calculation and data dimension prediction. All put together, we have dealt with a machine learning model to collect these data and come up with and valid SOH and SOC for an effective operation. And looking more into the EV performance in case of BMS, it is always better to operate in a desired temperature limit that is close to 15 to 35 degrees Celsius is where our lithium-ion battery works in a safer condition. And it should, once it exceeds this particular temperature limit, it would always open the pathway for the electron to move in the horizontal direction, starting with the breakdown of ACA and the electrolyte evaporation, and the last one is the cathode active material breakdown and oxygen release. So this oxygen release along with the existing lithium and the heat generation would result in a thermal runaway formation leading to a fire and explosion. And the BMS algorithm deals with the recurrent neural network, LSTM, and the gate recurrent unit. So these techniques would keenly monitor the current voltage and temperature of each and every cell, starting from the master and slave technique, and thereby we will deal with different cell balancing technique to pull down its voltage, talking about an overcharge and undercharge condition. And looking in detail about the health indicators for the battery, talking about the direct HI and indirect HI, capacity and internal resistance plays a key role. And in terms of indirect HI, average discharge voltage and maximum discharge current or the primary factor, followed by constant current charging time and constant terminal voltage charge put together combined with the charge temperature and charge rate will give you a clean idea. So the basic input for the BMS is voltage, temperature and current, and the basic output that we gather from the BMS is about SOC, SOH and the fault and status of your existing batteries. And our primary focus deals with the temperature as a primary factor. As the temperature rise, the whatever the pressure built inside the cylinder is getting increased, and it results in smoke formation followed by fire and explosion at the end. So you can clearly visualize that a minimal amount of heat addition from the external surface would drastically raise the temperature rise of your battery, and it would create a marginal pressure rise inside the battery, resulting in an slowly an explosion at the end. And talking about the thermal runaway and failure mechanism, we have attempted to deal with different puncture techniques and try to understand the smoke to flame propagation. And the basic idea about the thermal runaway is deals with the Sominov theory of thermal explosion. When the internal temperature is getting higher than the external temperature, it would result in the thermal runaway propagation. Focusing more towards the time constraint, I'll give you a brief idea about different thermal runaway mechanisms, starting with mechanical abuse, electrical abuse, and thermal abuse. Mechanical abuse deals with Russian penetration, where you are mechanically abusing the battery. And in case of electrical abuse, it deals with overcharging and undercharging condition. And in case of thermal abuse, it deals with taking the battery from the external source, all put together. If your internal temperature is higher than your external temperature condition, it would result in smoke, fire, and explosion formation. At the end of the day, if you look detail into the battery chemistry, you can clearly visualize the separated peering, separated piercing, and separated collapse. And focusing more on the mechanical abuse condition, you can visually see that one mechanical abuse is created, it would create an possible connection between anode and cathode. So that way, there would result a short circuiting formation. As a result, there would be a sudden peak rise in pressure and temperature where the voltage would drop from a higher level to zero, and at the end of the day, it would result in a harmful gas and high temperature flame occurrence. So hydrogen carbon monoxide are the primary output of it, and small droplets of organic solvents is also available based on the study that has been conducted. And talking about electrical abuse, based on different charge and discharge pattern, the separator present inside the structure would get disturbed, and this would result in the drop in voltage and rise in temperature. And talking about thermal abuse, trying to abuse the battery in terms of thermal from the external surface, of whereby the external surface of the battery is getting raised, and that result in the internal core temperature rise, leading to the high temperature formation of the cell, where the operating window exceeds its 15 to 35 degree Celsius level, resulting in a thermal abuse condition. So the basic issue is that the standard has not been finalized because the abusive conditions keep on differing, and the lack of harmonization and different TR methods and test setups need to be included, and controversy on internal short circuiting TR testing plays a key role, and the range of condition and the change of severity of the response result to abuse should be taken into account. Testing at a component level might be good, or dealing with a single cell is fine, but looking more into an entire battery pack is really a tough task. So aging influence on the battery is also a key role in the standards and regulation fixing issues. So these are the various challenges and related issues. And key gap that need to be filled is that the fundamental mechanism of TR need to be very much clear, and the link between the abuse and the time to initiate the TR need to be filled. And the type of abuse or the severity of the propagation should also be bridged in a clear format. An adaptive measure should detect the PR and limit the number of cells is one key area that we are working on. And focusing on module, pack scales, and different parameters should be taken into account. Academic research focuses on the prevention, whereas the propagation is also a key area that we can focus on. Further effect on the detection, computation, and the suppression need to be taken into account. So focusing more towards the time, I will give you some the research work that we are working on. So we are working on the battery fire suppression with the phase change made material, where we try to place the batteries inside a battery pack and filled with phase change material and try to understand how the battery fire intentionally affects the phase change materials and try to understand the impact on it. And we are also dealing with the ARC setup to try to understand different modules and the temperature rise for each and every battery, dealing with natural convection to forced convection, and dealing with phase change material combined with the carbon fiber to enhance the thermal conductivity of the existing phase change material. All put together, when you're just dealing with a passive material, phase change material with graphite and carbon fiber plays a key role in suppressing the battery external surface temperature based on different charging and discharging conditions. And we are also working on in-house project on onboard BMS and BTS separation, which includes the sensor data and IoT data intelligence that deals with majority of cases LSTM, and the cloud-based data are stored in it and try to understand the previous thermal runaway condition and early predict the existing case and trying to suppress the flame propagation and alert the driver in an effective way. So these are the different areas we are working on. And apart from that, we are working on an international project with Taiwan to where we work on the hybridization of vehicle with both internal combustion engine and the heat generation from waste heat recovery combined with the hydrogen addition to the entitlement. So this is what my entire presentation talks about, and thank you for giving me this interesting opportunity. I believe I have wound up within the time limit. Thank you very much.
Professor Dinesh, thank you so much. Very good subject. I think that is very critical today. We discussed together in the electric vehicles and thermal management of the battery, very problem. Not only the vehicles and air craft and other sectoral application, we see that the very big problem, thermal management. Dear participants, do you have any question? Professor Danish, one question about it, especially, you know, that for the considering that alternative batteries and related to for the vehicles, the control of the thermal management, the same or different application, what do you think about?
That is entirely different based on chemistries. The temperature rise and drop is entirely different. So the based on the chemistries is entirely different. Even for lithium-ion batteries, different chemistries result in different windows of operating days. So that is not exactly related with each other. But anyhow, the safer limit always lies within below 60 degrees Celsius. At any point of time, it should not exceed 60 degrees Celsius for an effective operation of lithium-ion battery.
For the university, what do you think about how they made the experimental studies for this? Which study is true for this about the thermal control of the battery?
We are just dealing with the TRC thermal temperature analysis study, where we will deal with a nail puncher study, a postmortem study. So once the postmortem is conducted, we will try to understand the in-chemistry variation based on the mechanical abuse and the electrical abuse condition. And that will give you a clear idea about how the battery would typically get affected based on the physical forces that has been applied on it. So thus, that will give you an interesting not on the battery thermal analysis, rather having an overview about it. The in-chemistry data along with it will be much more interesting.
Okay, thank you. Maybe we discuss together late about it, what we do together with the new projects. Thank you so much.
Thank you very much.
Thank you so much.
Happy to meet you again in another interesting occasion. Have a great day. Bye.
Thank you so much. Okay, dear guests, dear participants, another speaker, that design and thermodynamic evaluations of integrated waste heat recovery system, a case study approach is, I think, the Fatih Yılmaz.
Yes, I am here.
Okay, stage is yours.
Okay, thank you, dear professor. My name is Fatih Yılmaz. I am a full professor at the Sparta University of the Applied Science. Today I am going to talk about the integration of the waste heat-based heat recovery system, a case study. So this study is my master student Batu. Batu is not here because of he is working on the factory. The study outline consists of the motivation. First of all, I will give information, and then the second part, introduction parts, and the global warming, waste heat, and the integrated system importance. And the third part, you can see here in this system description, assumption, and the thermodynamics modeling. As a finally, I will finish and the result and discussion and the conclusion part. You can see in this figure, in this chart, our study main motivation, clean and sustainable production of the power hydrogen heating, that based on the waste heat based integrated system. The combination of the two organic cracking cycle in the waste heat recovery. The waste heat recovery is a real data temperature and the forestry factory. It's a 232 Celsius degree. As you know, energy is an essential part of daily life and the key driver of the modern society. As the global population grows and the industry expands, the demand for the energy continues increasing, and therefore producing the energy from the secure, sustainable, and environmentally friendly sources is critical for the economic development and the clean future of our planet. As you know, you can see here the primary global energy consumption 2022, oil, coal, and the natural gas. It's about totally that come from approximately it's a 82% come from the fossil-based fuels, while the renewable energy and nuclear together with consumption is about 80%. So the world energy here depends on the fossil fuels, such as oil, coal, and the natural gas. When these fuels are burned for the energy, they release into the atmosphere and the carbon dioxide and other greenhouse gases in the atmosphere. These gases give rise to many environmental problems, such as rising the seawater levels and global warming and other environmental problems. As you know, the most important ways to stop climate change and environmental problems, they are much more important methods, renewable energy sources, and then efficiency and effective use of the energy. That's cogeneration, telegeneration, and also multi-generation energy conversion systems. So the waste heat recovery is critical to improving the energy efficiency. Today, the technology makes it possible to capture and reuse excess heat from the waste of the factory and other purposes, such as heating and also producing of the electricity. Today, the industrial facility accounts for nearly it's about 30 and 40% global energy consumption. A significant portion of this energy is released as a waste heat after industrial process. When this heat is not recovered, it leads to both economic losses and also environmental problems. Recovery waste heat not only save energy but also reduce carbon emissions, playing a critical role and the combating of global warming. And another part you can see here, another part, the green hydrogen method, which is important to switch of the clean sustainable future. Because of the green hydrogen, as mentioned the first speaker, Cholpan, which is important because of hydrogen and then fuel cell burned is the only products of the water and also power. So green hydrogen can be used energy carrier and the fuel and the feedstock. That can be the required of the power. It's come from renewable sources. That is namely green hydrogen methods. And the second part, our system, you can see here is a waste heat flue gas in the integration of the two organic ranking cycle and the PEM electrolyzer. The PEM electrolyzer requires the power. It's excess power because of come from the turbine 1 and turbine 2, the power generation and the system. You can see in this system can be generated power and green hydrogen and also heating purposes. So the thermodynamic analysis, the primary assumptions are taken into account in this study. The values of 25 Celsius degree and the 100 kilopascal are chosen for the environmental temperature and pressure. The multi-generation system is steady in steady state working condition. The hex and the pump and the compressor and also turbine are adiabatic. The pressure losses in the plant and the component are negligible. Finally, the chance of the kinetical and potential energy and exergy, you can see it's corresponding exergy chances are negligible. So you can see here is a four balance main energy, mass balance equations, energy balance equations, entropy balance equations, and exergy balance equations. And finally, the energy and exergy efficiency you can see in the outputs divided by input systems. The net power generation you can see in the final equation. So the thermodynamic analysis part, you can see in the system can be generated net power capacity. It's a 722 kilowatt. Additionally, you can see in this system can be generated 0.000 5 kilogram per second green hydrogen generation. And we conducted a parametric study that can be define the system performance, how can be effect of the different parameters. You can see in the figure 2 and figure 3 the effects of the flue gas volumetric flow rate on the system heating power and also hydrogen generation in the left side and the right side overall system energy and exergy efficiency. You can see it's clearly that if the flue gas volumetric flow ratio is increasing, parametrically you can see in this system can be generated more heating ratio and the power generation. At that can be you can see also you can energy and exergy efficiency is also increasing trends. This other parts you can see figure 4 and figure 5 the effect of the flue gas temperature. The flue gas temperature is has a positive effect on the system, both of thermal system and thermal energy and exergy efficiency and the production ratio. And then the turbines of works the isentropic efficiency. You can see in this charts, if the turbine isentropic efficiency increasing, the power generation and also hydrogen generation is the same ratio increasing, but the heating loss is decreasing. Because of this decreasing trend, the mass flow ratio to heating loss is decreasing, and then heating loss is decreasing. And then energy and exergy efficiency, you can see turbine isentropic efficiency has a increasing trends. So we can clearly state that the turbine isentropic efficiency if increasing the system and works as more performance ratio. As a finally, this chart, the pitch point temperature of the heat exchanger, because of the system consists of the different heat exchanger. And you know, if the heat exchanger pitch point temperature is increasing, the system energy and exergy efficiency is decreasing. You can see in this figure 8. As a finally, a waste heat based integrated system has a potential to switch net zero emission with carbonous fuel. The developed plant covers the detailed thermodynamic analysis of the waste heat-based integrated plant that can generate power, heating, and also hydrogen. As a comprehensive thermodynamic analysis, which is energy efficiency and exergy efficiency and the exergetic dissipation ratio methods is also parametrically investigated. The model can be generated is 27 kilowatt net electricity and 0.00056 for 2 kilogram per second green hydrogen. And then you can see here it's about the heating load is computed as about 700 kilowatt. The overall energy and exergy efficiency you can see in this chart, in this figure, 56% energetic efficiency and 21% exergetic efficiency. As a parametric study give a rising the flue gas temperature and volumetric flow ratio leads to upsurge in the model's beneficial products, and then the performance criteria is increasing. The system efficiency drops as the heat exchanger pitch point temperature rises. And then I'm thank you again for your this session and also presentation. If there are any question, I will give reply.
Ben alacağım seni. Ben alacağım seni. Dear Professor, thank you so much. Thank you. Very good presentation. I think that is a very critical subject. Do you have any question, dear participants? One question about it. Professor, what do you think about the waste heat? You know that the waste heat recovery produce the increase the efficiency of the process. But what do you think about? Yeah, what do you think about the boundary of this?
Okay, thanks again for your this nice question. So I think I mean that if the temperature of the waste heat, the system is input the more enthalpy. So the system that works is a more energy and give a rise to energy and exergy efficiency. Maybe it's can the system is increasing. The waste heat based organic ranking cycle maybe and the steam ranking cycle which is important. And then we can be design of the temperature ratio. Okay.
Okay, thank you, Professor. Thank you so much.
Me too. Thank you again.
Okay, Professor, do you have any comments here? Professor Fatih?
Okay, I am here.
Yeah, okay. Thank you so much. Thank you for your contribution.
Thank you again, dear Professor. Have a good conference. Thanks again.
Thank you so much. Okay, dear participant, the other speaker, aluminum jet fuels on the turbojet engine cycle. There NS in here?
Yes, Professor, I'm here.
Yes, stage is yours.
Can you see the slide?
Yes, yes. Please, if you complete the 10 minutes, this is very thanks.
Okay, I will be quick as much as I can, Professor. Good morning, everyone, distinguished colleagues and professors and fellow researchers. It is a truly honor for me to be here today at this symposium to share with you the result of our recent study, which is titled Performance Analysis of Nano-Aluminum Doped Jet Fuels on the Turbojet Engine Cycle. Before diving into the technical details, I would like to say that the aviation industry is the most under pressure when it comes to efficiency, emissions, and sustainability, as you know. And we all know that the aircraft engines consume vast amount of fuel and contribute significantly to global emissions. So the search for new propulsion concepts and alternative fuel is not an academic exercise only, but also it is a global necessity. So this is where our study fits in. Our research explores how nanotechnology, specifically nano-aluminum particles, can be used as an additive in jet fuels to enhance performance. And that's why we start with that motivation. Every year, millions of tons of kerosene are consumed, and this is not only represent a huge economic cost, but also increase significant environmental burden. So ICAO and European Union make some research about that and make some policies about that to decrease that kind of significant environmental burden. These targets mean one thing: if we continue with the Jet A1 kerosene alone, even incremental improvements in the engine design, it will be extremely difficult to meet the sustainability targets. So Jet A1 has been a reliable workhorse fuel for decades, but there are some limitations. Its energy density is fixed, and its combustion leads to high levels of carbon dioxide and nitrogen oxide. And although advances in the combustor technology have reduced emissions, the basic chemistry of the Jet A1 still limits how much improvement we can achieve. So our answer lies in the fuel innovation, specifically enhancing conventional fuel with nanoparticle additives. Among all nanoparticle options, nanoaluminum is particularly promising. Aluminum is a very energy-rich element, as you know, and when reduced to nanoscale, it becomes even more powerful because the surface-to-volume ratio increases dramatically. So the studies have shown that nanoaluminum can increase lower heating value compared to Jet A1, shorten the ignition delay time, meaning the fuel burns more readily, and increase the flame temperature, providing more thermal energy, and sometimes reduce unwanted emission like carbon monoxide or unburned hydrocarbons. So these studies are very important for the basic combustion physics, but they don't tell us what will happen in real engine cycles. The motivation of our works beyond that, how do non-aluminum doped fuel actually affect the overall performance of a turbojet engine cycle? We wanted to see whether the theoretical benefits translated into practical performance improvements in thrust, efficiency, specific fuel consumptions when the entire cycle is considered. And equally important, we want to identify the limitations, and it is the important phase of that study. And now that we have seen background and motivation behind this research, let me move into aim and contribution of our study. The main aim of this work was to evaluate how non-aluminum doped jet fuels influence the performance of a turbojet engine cycle. So what is crucial here is that we approach this question in system level. First, we wanted to analyze the thermodynamic impacts of the non-aluminum fuels. In other words, when you put that fuel into the jet engine, how do the main performance indicators such as net thrust, fuel flow rate, specific fuel consumption, and thermal efficiency? Secondly, we deliberately chose to work with a fixed engine architecture. This is important. We didn't redesign by the compressor, we didn't change the turbine or some kind of engine elements by keeping the turbojet structure constant. We ensured that any difference in performance comes purely from the fuel itself. Third, to achieve that, we used GasTurb 14 software and also our MATLAB built-in model, a cycle analysis tool which is widely used both academia and industry. Fourth, we didn't stop at the system level numbers. One of the distinctive contribution of our study was to integrate these results with the CFD-based flame core temperature data from the literature. So,
Enes, your slide 6 now.
Okay. So to summarize that contribution of study, system level evaluation of nanofuels, controlled architecture, reliable modeling, and integration with CFD literature was our main objectives. You can see the stations of the model turbogen engines, and you can see the sample test result data of the engine performance output. This is before non-aluminum addition result data. And this is the gas turbine modeling systems interface as a example. So methodology for this study, as I mentioned before, we use gas turbine 14 and we use that design point and off design condition with high accuracy. And turbojet engine is the simplest form of the gas turbine engine, and so we use turbojet engine. Air enters through the intake, gets compressed, passes into the combustion chamber, and the fuel injected and burned. And it is the great way to analyze our study. So by choosing the turbojet, we created a transparent environment where all of non-aluminum fuel could be observed directly. And in Duster, we defined the baseline design parameters, and we choose the parameters with regards of that. Lower heating value, temperature of the baseline, and nano AI additive part. So simulation setup, we used, as I mentioned before, Duster 14 software. Model was single spool turbojet without bypass, meaning that thrust is generated directly from the combustion exhaust. And this setup allows us to clearly see the influence of the combustion temperature of the thrust. So fuel cases, we get I can pass that parts and result parts. Now, first set of the results focusing on the main performance outputs of the turbojet engines. Net thrust, fuel flow, and specific fuel consumption. We make a result from that. So we get a great increase in net thrust and fuel flow, but specific fuel consumption is nearly same in the regard of the result of our study. And thermal efficiency is a little increasing thermal efficiency, and flame core temperature is highly increased in our research. And as I mentioned before, we get a 14.9 increase of the net thrust. We got 15.7 increase of the fuel flow rate, and we got nearly same and 0.5% of the thrust-specific fuel consumption. A 1.5 absolute gain, and flame core temperature is highly increased. These values match CFD predictions, showing good relation between the system level and local scale analysis. So the effects of non-aluminum additive fuel on turbojet engine performance can be summarized: net thrust increase and energy density gain because lower heating value has been increased, and improved in the thermal efficiency, not as a big kind of improvement, but it is a slightly little kind of improvement, and local temperature prediction and CFD correlation, and system level analysis with the CFD integration. We made that for our future processes. And for the discussion part, now on the positive side, we achieved substantial thrust increase, clear improvement of the thermal efficiency, and specific fuel consumption rate remained the same, constant essentially, and we need to get some discussion parts. So what do these results mean? Positive outcomes: more thrust, higher efficiency, specific fuel consumption remains stable, but challenge fuel flow significantly increased. Cooling demand and turbine material stress also increased because of the temperature rise, and extra chemical energy is not fully converted into useful work. This means that while nano-aluminum fuels are promising, they require structural and cooling system adaptations in the engines. So the limitations and engineering constraints observed with the scope of the study.
Last 1 minute, Senes. Okay.
The limitations and engineering constraints observed within the scope of the study can be categorized like limited change in specific fuel consumption. Despite increase in net thrust, specific fuel consumption has increased very little, slightly little, with terms of the net thrust. This indicates that the additional energy has not been fully converted to useful work. Significant increase in fuel flow. The fuel flow was increased in 15.7%. This situation can be explained by the increased cooling demand due to the rising temperature and the effect of automatic flow balancing mechanisms and post-combustion temperature distribution. The high local temperatures formed in the flame core may have affected the homogeneity of the mixture and the temperature profile at the turbine inlet. And CFD gas temperature difference, since the gas software is based on average temperatures, the actual maximum temperature inside the combustion chamber can only be estimated based on literature. In system structural requirements, we require additional cooling, engine components, material durability, and heat management solutions. And limitations on efficiency due to the fixed engine architecture, the energy potential offered by the additive fuel has not been fully utilized. So, as a conclusion, nano AI fuels improve thrust and efficiency, fuel consumption constant, engineering challenges, cooling, durability, and emissions has to be discussed in the future. And I mentioned this before, and no need for the repeat again. And future work, the future research should address optimal nanoparticle size, concentration, and dispersion, and integration with the sustainable aviation fuels like the biofuels and e-fuels, and advanced multi-phase CFD modeling for the real flight conditions, and emission studies including nanoparticle exhaust impacts. By combining fuel innovation with engine redesign, we can move toward more efficient and sustainable propulsion systems. These are the references, and thank you for listening. I hope I didn't get extra time from you, Professor, and thank you for listening.
Thank you, Enes. Thank you for your good presentation. I think that nanoparticles is a very critical subject. Okay, dear Mustafa Turhan Çoban. Yes, Professor Çoban, do you have any question or contribution here?
Open the world. I'd like to mention something. These aluminum particles might improve our thermal efficiency, but what is my concern is aluminum particles. We do know that even as a food containers and small particles from them is affecting brain particles. More clear things make people stupid. That is a effect that is a known fact about aluminum, and you might remember that we used to use lead in our fuels, and it had really serious effects too. So as far as environmental effects, and as you know, in all jet engines, it is an open cycle, and we are just sending all the particles to environment. What do you think about this kind of environmental effect might cause about this kind of application? Thank you.
Thank you so much for that improvement question, Professor. And I am strongly agree with you. The environmental effect of the nanoparticles have to be researched before used, but the main phase of the kerosene jet A1 engine has also very much effect on the pollution, and so that kind of a little nano particle additive maybe, as you mentioned before, make a bad results in the environment. But yes, we have to be careful about that. But it is the main question for the emission, or for the fuel emission systems improvements. And so, yes, I agree with you.
Thank you, Enes. Thank you again for your presentation. The participants, the other speakers, Hacer Akhan here.
Yeah, I am here, Professor.
Yes, energy assessment of the photovoltaic thermal system.
Yeah.
Please, stage is yours.
Thank you.
10 minutes, please.
This is my presentation?
Yeah.
Okay. Thank you, Professor Söğüt, ladies and gentlemen, and fellow engineers. My name is Hacer Akhan. I am from Trakya University Mechanical Engineering Department. I will make a presentation titled Energy Assessment of a Photovoltaic Thermal System. Firstly, I will introduce the PVT system that was installed in Edirne. Then I will explain the methods, materials, and the results of analysis. PVT systems are becoming increasingly important as they allow heat obtained in photovoltaic panels to be used and the panel to be cooled. On the one hand, cooling the solar cell increases efficiency. On the other hand, the heat is obtained. The map shows the energy field of Trakya University Engineering Faculty, where the system was installed. The energy field is situated in 41 degrees latitude and 26 latitude. The table and the picture shows the components of photovoltaic thermal systems. In the study, 1 unit, 280 watts polycrystalline solar panel integrated into the transpired solar collector. The figure shows the schematic picture of the off-grid PVT system. The most important component of the system is the transpired solar panel, which absorbs solar energy. This facade cladding system is made of metal material and is usually mounted on the exterior of buildings. The table below shows the technical specifications of photovoltaic panels under laboratory testing conditions. The efficiency of photovoltaic panels made of polycrystalline is 18%. The absorber panel heats up in response to solar radiation and takes to its many special designed micrometer-sized holes, hits the outside air and sends into the indoor environment. Due to this structure, transpired solar collectors are one of the ideal systems for PVT system applications. The table shows the technical specifications of the transpired solar collector. The figure and the table show where the system's temperature measurements were taken. The map illustrates the long-term average of global horizontal solar radiation. As evidenced by the map, the solar radiation in Edirne is approximately hours per square meter. The figures show the average hourly solar radiation and the average ambient temperature in the energy field in 2021. The average ambient temperature is up to 40 degrees Celsius. Equation 1 is used to calculate the efficiency of a PVT system, and equation 4 is used to calculate the thermal power of the system. The figures show daily electricity and thermal power generation in the summer of 2021. Diagrams illustrate the cooling performance of the photovoltaic thermal systems. The figures show the power generated by the thermal collector as well as the efficiency of the photovoltaic thermal system at different levels of solar radiation. In the summer of 2021, the system under review produced a total of 34,391 watt-hour of electricity energy and 791,973 watt-hour of thermal energy. The analysis results show that PVT system is the best option for meeting the electricity need of buildings in Edirne and other places with similar climates. This study was funded by Turkey University Scientific Research Project Unit. Here are my references, and thank you.
Okay, thank you so much for this presentation. I think that experimental study is critical for this, especially to define the PV poverty panel application. Maybe we discuss, you discuss on the performance, considering that the classical applications of the PV panel and the heat panel impact on the, how it affects the performance considering that efficiency?
Yeah, it's affected 30% better than a standalone PV system. We make a project. In this project, we work on a standalone PV panel, and the other one was PVT system. Now I can see. I can show this system for you. Yeah. This is standalone PV system, and the other one is PVT.
Okay, thank you so much. Thank you for your presentation.
I thank you.
Thank you. Okay, the last speaker, the Sena Erkentin here.
I'm here.
Okay, stage is yours, please stand, miss.
Okay. Can you see my presentation?
Yes, we can see, but please open the presentation. Okay.
Okay. My name is Sena Erkent. I'm PhD student of the Environmental Engineering. In this presentation, I will talk about our preliminary findings. We are still performing our experiments by using our custom fluidized bed systems. The February 6 earthquake in Turkey generated approximately 200 million tons of construction debris waste. It's also stated that a significant amount of the country's building stock should be recycled in preparation for the Istanbul earthquake. It's accepted that approximately one-third of the demolition waste resulting from the demolition of an average reinforced concrete structure is concrete. Concrete, which constitutes a large portion of the waste in our country, is mixed with other wastes and transported to the regions permitted by the municipalities with licenses transports vehicles by the regulation on control of excavated soil construction and demolition waste for disposal and or use filling material, especially after the earthquakes of August 17 and February 6. There is a great need for more sustainable management of debris waste in our country, both environmentally, socially, and economically. Carbon dioxide is one of the greenhouse gases whose concentration in the atmosphere has increased remarkably in recent years. Increasing carbon dioxide concentration in the atmosphere has a negative impact on the environment. In line with these goals, utilizing construction demolition waste for carbon dioxide removal and managing demolition waste from a circular economy perspective is important, both in significantly reducing an amount of demolition waste, supporting the development of sustainable and resilient infrastructure, and reducing pressure on local waste management systems in urban areas. The aim of the study, as mentioned at the beginning of the presentation, is to address demolition waste in an environmentally friendly manner. Therefore, the study also investigated the carbon dioxide gas absorption potential of demolition waste. Before the experiments, demolition waste was first dried at 105 centigrade degrees for 2 hours. In our preliminary experiments, we investigated the carbon dioxide capture performance of raw demolition waste for 4 different holding times under 100% carbon dioxide atmosphere using 2 grams of demolition waste with a similar 1 millimeter diameter in horizontal furnaces set as 130 centigrade degrees. Then thermogrametric experiments were carried out at heating rate of 10 centigrade degree /min in nitrogen gas atmosphere in the temperature range of 30 with 950 centigrade degrees to determine the carbon dioxide absorption capacity of demolition wastes at the end of the holding period. From the 450 to 900 centigrade degrees temperature range, the carbon dioxide absorption capacity of demolition waste was calculated by using mass loss, and the results were corrected with raw demolition wastes. Furthermore, after the experiments, demolition wastes were examined with CEM and EDS and XRD analysis to detect their contents. Figure 1, the thermograms with demolition waste at 4 different holding times. The absorption capacity of demolition waste was 0.0046 mg carbon dioxide /milligram demonstration waste for 6-hour holding time, 0.0114 mg carbon dioxide /milligram demonstration waste for 10 hours holding time, 0.0066 mg carbon dioxide /milligram demonstration waste for 14 hours holding time, and lower than that non-treated raw demonstration waste for 20 hours retention time. Accordingly, it was observed the highest carbon dioxide absorption occurred at 10 hours of holding time. No absorption occurred at holding times below 6 hours, but absorption occurred over 20 hours of holding time. The figure 2, the same images of selected samples for raw demonstration waste and 10 hours and 20 hours holding times demonstration waste. Although EDS analysis calculates the oxide form is stoichiometric, it is seen in the study that the sample starts to calcinate at the 14th hours and the calcination of the samples continued at the 20 hours. Furthermore, the lowest calcium oxide content and highest carbon with oxygen content in atomic weight percent were observed for 10-hour holding time for the demonstration weight according to EDS results. The understood that the EDS results are in parallel with TG results, and the reason for the lower absorption of the samples kept the 24-hour in the TG results as the samples are calcinated and carbon dioxide release occur. Based on the TG, SEM, EDS, and XRD analysis of the raw, demolition waste, and treated samples, it is understood that the carbon dioxide capture capacity of raw demolition waste was found to be 0.0046 mg carbon dioxide / milligram demolition waste for 6-hour holding time, 0.0114 mg carbon dioxide / milligram demonstration for 10-hour holding time, 0.0066 mg carbon dioxide / milligram demonstration waste for 14-hour retention time, and lower than that of non-mineralized raw demolition waste for 20-hour holding time. In parallel with the 3D results, it's seen from the EDS and XRD results that the highest carbon dioxide absorption occurs especially in the sample kept for 10 hours. We would like to thank Seydu BAP due to their financial support. Thank you for listening.
Thank you for your presentation. Thank you. Okay, the audience, the participants, do you have any question for this presentation? Okay, thank you, Sena. Thank you again. Thank you for contributions of ISEMAS 2025. The participants, now we start the closing remarks of the ISEMAS 2025. And first of all, thank you all participants, and thank you the Piri University Rector, Professor Nafis Arıca, and thank you the keynote speaker, invite speaker, and presenter for all the papers. And thank you the organizing committee, and thank you Sofia, thank you Çakan, thank you Orkun, thank you Nilay, Nagihan, and Selvi. And before closing this session, I would like to hear your thoughts and ISEMAS 2025. For this, please give us the opinion about what we do together about 2025. Yes, Professor Çoban.
Okay. Is my voice coming?
Yeah.
All right. Thanks a lot in the first place for all this organization. It was a great organization. I personally really enjoyed that. What I would like to say, of course, these kind of things should be continuous. But by the way, we had something similar that I would like to continue on next year. It was called Thermodynamic Properties of Materials Conference. We are planning to achieve that if we can next year about these times. It could be both online and offline, so personally as well. It used to be traditionally done every 2 years between Germany, Turkey, and Azerbaijan, and from other countries as well. It was an international seminar, and some of our organizers unfortunately died, so it was just quit. Hopefully, we will continue that on after this. We already have the participant list of these ISEMAS. We can just let them know, and other peoples and friends as well. So hopefully we will meet again next year all together in a good and wonderful conference in this place of Piri University. Thanks a lot for that.
Thank you, Professor Çoban. Thank you for your contributions again. Professor Utlu? Professor Utku, your phone is closed. Please open your phone.
So sorry.
Yes. Say.
Okay. First one, I would like to sincerely thank Professor Ziya and his team, and also all keynote speakers, presenters, session chairs, and attendants for their valuable contribution and thought this symposium. The symposium is very best symposium, and also this is online symposium. However, it's very successful in terms of a lot of papers and a lot of different subjects. And however, for future symposium includes to me and future expand international collaboration and participation highly and encourage more interdisciplinary research presentation and enhance interactive session includes workshops and panel discussions and also provide great opportunities for young researchers and students to share their works. And lastly, this is very best symposium. Thank you again, first Professor Ziya and his team.
Thank you so much, Professor Utku. Thank you for your contribution and support all part and all the studies. Thank you so again. There Utku Kaleyan here.
Yeah.
Yes, Professor. Thanks very much for letting me know to speak up. Basically,
special thanks for your support, all the parts.
Professor, really, that's our great pleasure because, as not only the Budapest Technical University, Amsterdam University, and Vilnius Technical University I'm supporting along with the EU Commission, but also all my international research team, you open the doors of ISEMAS and you allow them to present all our valuable papers. That is something that I feel ourselves like our home, this ISEMAS. So whenever it will be held, of course, I will take all my international team and proudly be part of the ISEMAS 2026 and the coming ones. So basically, one great thanks goes to you, Professor Ziya, because if you also allow me, I would like to tell some word about our activities with you that with you not only at the ISEMAS conference, but also I had personally very long-standing relationship with Professor Ziya, with the Vice Rector, along with EU and non-EU level collaborations and representing the EU bodies and really greatly conducting many close meetings in the research, industrial, and also NGO bodies along with Professor Ziya. He is also supporting all our PhD and postdoc students during the defense process at the Amsterdam University, Vilnius Tech and Budapest Technical University. So I think we cannot be grateful for you a lot, Professor. So this is also a way for us a platform to meet up with you and with your great team that you are working at the Piri University. And also special thanks that last time you opened the doors of Piri to my team in person, we had a chance to see you there. It was a really great pleasure. I don't know, have you already announced the 2026? Should we tell some word or you will go ahead, Professor? ISEMAS 2026. Would you like to tell some word about this or should we go for announcement?
Yes, we announced that we studied together the videos, that we will play it's a critical subject based on hybrid or the other parameters we discussed together about it.
Professor, just before I'm coming here, I had a phone call from Vilnius Technical University, and they highly support to you to organize this conference in person at Vilnius Tech, and they open all the doors for you entirely to organize it in a really in-person mode or hybrid mode, which you can welcome all the participants. So all the doors is open, I will tell, but you don't have any door exist, so you are highly welcome, Professor.
Yeah, critical parameter for us. It is very important to support young scientists, especially considering the cost of the symposium. It is very critical for us. We discussed together about. Thank you, Utku, again. Thank you so much.
Thank you for your support, Professor.
Dr. Mehmet here.
Professor, thank you very much. First of all, it's a privilege to attend to this symposium for me, and the presentations were very effective. I hope I have attended 2 or 3 sessions, and I saw an experimental works and the projects. I hope to see the results in the upcoming symposiums, on the same symposiums. And the theme of the symposium is on the agenda, as we follow. And it was an honor to me to present my also study. I hope to see maybe we can invite representatives from the engine manufacturers to make the symposium more practical and see the practical results on the site. I hope to attend again, and for me it was very good. I know your efforts, and I know the organization, and behind the door there are many works and hours studies. Thank you very much for everything. I hope to see you again face to face. I hope the symposium to be face to face. I would prefer face to face, a more hybrid symposium actually, because on face to face there were more effective conversations are ongoing. So see you. In
Thank you so much. Thank you. We discussed together with Professor Turan about it. He prefer about new double conference in our previous university. We made it next year about it. Maybe we made it together in the. We made it together for Utku and with Mehmet and with Zafer, Professor Zafer Utku together. We discussed together about it. Thank you so much, all of you, for give us very special support or each steps. Thank you so much for all
it's my pleasure.
Okay, thank you so much. Thank you. Okay. Do you have any different idea, any comments, the audience, please, if you have, please share with us. No? Yes. The end of the symposium. Sofia here?
Yes, Professor.
Yes. Last sentence, please.
Okay, now, on behalf of the organizing committee, I would like to thank all of our keynote speakers, invited speakers, and our session chairs, and all of the participants for their contributions throughout these 3 days. We hope that the discussions and collaborations that started here will continue to inspire and shape the future of energy management and sustainability. Thank you all, and we're looking forward to meeting you all in the future, ISEMAS 2026.
Thank you, Sofia.